Mi dice l'organizzatore ha disabilitato.
Infatti si deve fare, si deve rendere chi è l'organizzatore?
Ah, ok, ok, perfetto. No, ok, Paolo è arrivato.
Devo recuperare il vostro documentato.
L'hanno già aperta ora per la prima volta. Mi sono accorto, ho cambiato il computer da poco, fino a no, i miei datatori per proiettare non ho più bene.
Non c'è problema.
Ho la chiavetta, quindi si possa proiettare.
Sì, c'è Domenico che sta raccogliendo tutte le ragazze che sta raccogliendo tutte le presentazioni, quindi utilizziamo un unico computer.
No, c'è una chiavetta da mettere. Perché ma l'avevo già caricato sulla mia chiavetta. Per la legge di macchina.
la recupero online.
C'è qualche parte c'è Posso già parlare?
Okay, I hope you can hear me. Yeah, we are starting in a few minutes. We're just setting up the last details.
No, okay.
Ok, cominciamo. Vabbè, dai, possiamo cominciare. Okay, here we go. So welcome to this 11th edition of this of our workshop. This workshop of the Italian Community for Information Retrieval. It is a pleasure to host this this event here in Bari this year, specifically because maybe this is the first event in person that we are attending since last 2 years. So I'm very happy to see many friends here, many PhD students. This is the main aim and the main spirit of this workshop at the end of the day. So we really want to build this community around young people, and we really want to grow this community around young people. Well, actually, also not young people, have a role, but we really love to see you. So before we start, it is a pleasure to me to ask Eugenio Di Sciascio to say a few words. Eugenio Di Sciascio is a professor here in computer science. He's a former rector of Politecnico di Bari, and right now he's vice mayor and councillor for innovation for the city of Bari. So it is a real pleasure to have him here also, and to listen to a few words from you. Please, thanks.
Thank you, Tommaso. I'm quite glad to welcome you today here in Bari on behalf of our municipality, and we're really glad to have you here. This is the third, for me, conference with people present in the last month. So it's important for us to see you here. Because this represents the idea that life is coming back. We all know that it's not going to be the same as it used to be, but we also are in a process that will change, we hope for the best, the way we live and the way we believe, in cities in particular. Cities are at the center of any change at the present time. So this is also the reason of my commitment to the, as vice mayor and responsible for innovation in our town. But I think that we also as scientists, as researchers, have a responsibility, a particular responsibility in this time. Because this is a time when information retrieval becomes really of paramount importance when you move it to the real life. And so we have a real responsibility, because the theme of trust or truthfulness in information is really a theme that was, but it has become also in these days, in this current time, a thing that's really important for our future, for the future of how life will be perceived and will be lived in the next months and the next years. So I won't take you any more time, but I really wish you the best success for this workshop. And I know you'll have some extremely interesting talks. And I hope that this workshop, therefore, is really an opportunity for you all to deepen your knowledge about the IIR, but also, I have to say that, you have the chance, the possibility to visit our city, our beautiful town. Also to have air conditioning would be great, but this is not in my power. And also, I was saying, I hope that you have the chance to visit our town and also appreciate some food delicacies, but also the possibility to have a stroll to visit the old town, which are really part of the heritage of this town that has been, there are several historical places, but also a long history of communication, of dialogue with the East and the West. As is the motto of our city, no one is a stranger in Bari. So I hope you feel at home in these days. Thanks. Have a nice one.
Thank you very much, Eugenio, for welcoming us in the city of Bari. So just a few words about the workshop, about this edition of this workshop. And yeah, this is, we start with the number of submissions. So at this workshop, we have 7 long papers, 5 short papers, and 27 extended abstracts. So, what an interesting number of submissions. So this witnesses somehow, that this community is a lively community, and this community really wants to meet, to join, and to discuss. And what is interesting here is that submissions are from people, well, mainly in Italy, but we also have someone from Switzerland, but it is almost Italy, we know that. But we also have submissions from UK, Israel, France, and also there is a paper co-authored from by someone from Australia. So we're very happy about this information that again is a good mark for our workshop. Well, as for where the submission come from, we have to say that we have very strong supporters at University of Milan Bicocca. So they submitted 6 papers. So we really thank them for their support to this workshop. And then we also have the University of Padua with 5 papers, and then we have University of Pisa and Politecnico di Bari with 4 papers, and then we also have other universities with at least 1 submission. So this is this is something that we really appreciate it. And also about the registrations, we have, well, of course, we have many people who registered from Politecnico di Bari, but we have many people from different universities and research centers in Italy, but not just in Italy. And this is very interesting to us. But I think that the most important information is about the number of people who registered for this workshop. We had 91 registrations. And 31% of this registration are from people who will attend the workshop virtually, and 60 people will be here during this day. So I think that also this is a very good sign about this workshop. Well, before we started the workshop, we asked some of you to tell us where this community basically publishes their work. And this is the partial result. I see that this is partial because I think that we can continue collecting this information just to see where we are publishing, or which are the main conferences where we build our where we build our network. And we see that as we expected at the end of the day, but the main conferences where this community of IIR publishes are CAKM, CIIR, European Conference on Information Retrieval, ACL, WWW, Rexis, and Wisdom. So these are the main conferences we are currently publishing. Well, when we ask the community to indicate the conferences where they publish, we ask for the main conferences. Okay, so we ask for top conferences basically, and those are the top conferences where we are there. So we can surely say that the Italian community is very active in all these top conferences, and this is very good also, and especially for you, PhD students and young researchers. As for the journals, we have IPM, IR journal, expert systems with application, and toys, of course, as we expected. But also in this case, it is important to see that there is a strong contribution of the Italian community to this research. Okay, now we move to the organization of this edition. I do need to thank all the people who contributed to the organization of this workshop, because they worked really a lot, I have to say. Let me particularly thank Walter Anelli, who is not here because he's collecting people around the campus. There's someone who got lost, so he's going around collecting people. Thank you very much, Nicola and Lucio, who worked on the interesting program of this workshop, and Yashar and Maria for the selection and the organization of the tutorials. And a very big thank you to Stefano and Antonio and Claudio, who organized all the logistics and all the stuff, here in this workshop. I'm very happy to say that we have these sponsors who are allowing us to have this interesting coffee breaks, welcome receptions, and lunch. So we are they are offering us a lunch for the next, for today, no, for tomorrow, right? Yeah, and yeah, especially also let me thank Auriga, because they are sponsoring the 2 best papers awards. So we will have a best short paper award and a best long paper award. They will be awarded with 500 euros each. So this is not that bad. Especially if you're a PhD student. We know that PhD students also are they are not very rich. So this is everything related to regarding the organization of the workshop, and everything regarding the main elements of the workshop. And about the program, I would like to ask Lucio to continue to say something. Thank you.
Thanks, Tommaso. I'm really proud and excited to serve as a program co-chair for IIR, because IIR for me represented one of the first appointments with the research community. And in addition, this year, for many PhD students, this is one of the first events that they can finally attend in person, given to the previous pandemic restrictions. I want to thank Nicola Ferro for the very excellent collaboration and cooperation in this work. This year, the program is really rich. We have 3 keynotes, 4 paper sessions, and 2 tutorials that are one of the novelties of this edition. The first keynote is by Paolo Cremonesi, and it will start immediately after this opening. And in this keynote, Paolo will show us what are the best practices that his group has detected in several experimental evaluations in the recommender system field. The second keynote is by Omar Alonso. It will be tomorrow morning. And Omar will touch one of the hottest topics in the research community, such as the knowledge graphs. In particular, Omar will discuss with us what are the challenges and opportunities in building domain-specific knowledge graphs. The third keynote is by Elvira Brattico, and is a sort of special treat of this edition, because Elvira is a neuroscientist, and she'll try to bridge the gap between information retrieval and neurosciences, in particular in the music domain. We have also 2 very interesting tutorials. The first one is by Nicola Tonellotto. Nicola will introduce classical and most recent re-ranking techniques by exploiting PyTerrier and OpenAIR in a very exciting and interactive tutorial. The second tutorial is by Elizabeth Lex and Marcus Schell on psychology-informed recommender systems. So Elizabeth and Marcus will show us how to predict the user behaviors in order to improve the recommendation process. We have 4 paper sessions. The first one will start after the Paolo's keynote. Tomorrow we have 2 sessions, the first in the morning and the second in the afternoon. And the last session is on Wednesday morning. IIR will end with the award ceremony, where the best short paper and best long paper will be awarded. As Tommaso Prioli said, the awards are sponsored by Aurelia. So, thanks so much for attending this conference. We hope you enjoy the conference at this beautiful city. Thank you very much. Okay.
Before the end of the talk, I will fall down from the. You know, in many research, experimental research areas, reproducibility is one important pillar. You discover something new. I don't know, you discover the Higgs boson. You do an experiment, okay, and you claim you have the empirical proof that you have seen the Higgs boson, but someone else has to replicate your discovery because, okay, we are sure that the discovery is true, okay? And so, you know, this is something that we should do also in computer science and in information retrieval and in recommender systems. But in the recommender system community, you know, the reproduction of experiments is something that you seldom do. And we will discuss about this, okay? And so, you know, our work and also other works, okay, came out with a number of important conclusions. The first one is that there is a lack of reproducibility in the Rexis community. And this is something that I will not discuss too much today. Okay, today I will not discuss about the lack of reproducibility, if not marginally. And then, you know, the problem is that together with the lack of reproducibility, there are also a number of technical and theoretical errors in many of the papers that we surveyed. And these errors did not emerge because of the lack of reproducibility works. If you do not reproduce an experiment, you are not able easily to detect errors, okay, in the claim, in the published experiments. And all of this somehow, okay, is pushed by a number of scholarship of practices that do not promote, do not push researchers to focus on implementation details, on some of the issues, to put attention on some of the issues I will tell you about, and also on reproducibility. So I will start by, you know, giving you a brief overview about the work we did at Politecnico di Milano. So in the last 3 years, more or less, we systematically scanned all the papers published in the conferences you see there, okay, dealing with the usage of deep learning algorithms for a specific problem in recommender systems, which is called the top N recommendation problem. Okay, why this specific problem? Because it is the most common, okay, problem, the most common task, which is addressed in the Rexis community. And so we were able to reproduce 30 papers, more or less, and the results of our reproducibility experiments have been published, okay, along the years in different publication venues, and there are results that we have to still publish. And you know, and I will show later on the results and what we discovered. But before we go on, it is important to understand which is the typical approach when you write, when you do research on recommender system. Okay, so typically the typical approach, I'm talking about algorithmic recommender systems. So you have a new idea, a new algorithmic idea. So what you want to do is that you want to experiment with your new algorithm against a number of baselines. And of course, the expected result is that your new algorithm is able to improve, okay, some quality indicator on some data sets against these baselines. And
sorry to interrupt, but we cannot hear you.
along the years, you have dozens of papers, each one addressing one specific small innovation. Overall, if you look at the papers published in the last 3 years, you have maybe hundreds of improvements, okay, small improvements. And if all of these improvements are able to add up, so if you can accumulate all of the improvements, the quality of today recommended systems, okay, you see, I fall down. The quality of recommended systems today should be fantastic with respect to the quality of recommended systems a few years ago. But this does not happen. Okay, why? Okay, we will see why does it happen. Okay, and so the main outcome of our research activity was that in almost, there are a few exceptions, okay, 1 or 2. Okay, but except for these exceptions, the truth was that, and is that, all the deep learning techniques proposed in the papers that we scanned were not able to do better than a simple baseline. Okay, when I'm talking about a simple baseline, I'm talking about simple KNN approach or simple linear machine learning models. Okay, and but as I was saying, this is not the goal of my today's presentation. And you know, and today the goal is to discuss why does it happen, which type of errors researchers were doing in their experiments. Okay, and I would like, even if what I'm going to tell you today is mostly the output of our work. This type of issue is, you know, present probably also in the broader IIR community. And, you know, if you know, there was a paper that, you know, raised a lot of discussion from Jimmy Lee in the SIG-IIR forum. I think it was on December 2018. And then there was another paper, you know, addressing the same issue from, you know, with a more structured approach, critically examining the neural height. And in this paper, you know, the authors analyzed 130 publications that reported results on the 2004 robust track. And the papers were collected by a number of publications. I don't know if I can move this window a little bit so you can see better. And so the publications were published between 2005 and 2018. And well, this chart is taken from their paper, okay? And if you don't know this publication, this diagram is, in my opinion, impressive, okay? Because the dark line here is the best submission at the track in 2004. And the red dots and blue dots are the performances of papers, of algorithms published in papers submitted after the track, the robust track, okay? As you see, almost all of them are not able to do better than the best submission at the track. And here you see typically this dot is the proposed algorithm, and this is the best baselines that is used in the paper. Okay. So the paper each paper compares against a number of baselines. So you see one of the baseline, the best baseline, and the improvement. Okay, so in that paper, the author show an improvement with respect to the baseline, not with respect to the best available algorithm. Okay, and the blue dots represents the deep learning approaches. Here I want to talk about deep learning versus the rest of it. Here I want to talk about bad practices. Okay, and this is to tell you that you know, the problem is present not, as I was saying, in the IIR community, not only in the Rexis community. Even if I do not have, let's say, practical hands-on experience, And however, there is a huge difference between the two communities in terms of good practices and in terms of reproducibility. And the big difference is that in the IIR community, in the financial retrieval community, typically the evaluation of a new research paper is performed against a data set and a set of evaluation procedures that are considered a standard in the community. And the data set and the exact evaluation procedure is detailed in the standard somehow. While in the Rexis community, there is no detailed standard. There is a kind of set of high-level guidelines. So almost everyone uses the same set of data sets, okay? But not exactly, and not always, okay? Almost everyone uses more or less the same. Okay, do you want me to speak closer? No,
no, I think it is. Could you hear it now? Okay, perfect.
Thanks, grazie.
Sorry for that. Okay.
Okay, good.
Yeah.
Thanks, grazie.
Click on the slide too.
Yes, okay.
Non sono nello slideshow, ma va bene lo stesso. Sì, va bene così, va bene così. No, senza mascherina. So in the Rexis community, there is no sharp standard, okay? There are generic guidelines, but this, we will see later that these generic guidelines are not enough for reproducibility and are one of the reasons why there are these errors, okay, that are present in many of the published papers. Okay, and so the only, let's say, real, let's call it standard, is that there are few papers that when they use a baseline, a previous baseline, in order to avoid to rerun the previous experiments, they use exactly the same evaluation procedure as in the baseline. Okay, and the goal is here is to avoid to retrain or rerun experiments, which makes sense. Okay, but these are not standards, let's say, coming from the community. They are coming from single authors. Okay, so they are short-lived standards. Okay, they exist for 1 or 2 papers and then they disappear. Okay, so the question is if we do have a crisis in the recommended system community, and I would like to have a crisis because, you know, having a crisis means that the community is aware of these problems and is taking actions. Okay, but frankly speaking, there are some exceptions. Okay, so some of the communities, some of the, for instance, the publication venues, they are aware of this problem and they're trying to, let's say, take actions. I want to mention 2 examples. Say IKM and Rexis, they have a reproducibility track. Okay, so and this is a step forward trying to solve these problems. Okay, but not all the publication venues are aware of this. And so I think we should try to do more on this. And by the way, this is only the introduction of my speech. So if you think, okay, you're finished, no. So the goal of my today's speech is to show you the most common errors we discovered and to try to give you our opinion on why these errors are common, and which are the actions that you as authors, but you also as the community can try to do in order to prevent these errors. And so, like in many research area of information retrieval, the goal of research of recommended systems, on algorithmic recommended system, is to build an algorithm which is able to make the best prediction for a user, and prediction of items which are relevant for a user. And the goal of research in this area is to improve the quality of these algorithms. And you know, there are different type of tasks that you can try to solve on recommended systems. But the most common task is what is called the top-end recommendation task. So you recommend n items to a user, and you wish that all of these items are relevant for that specific user. And so research on recommended systems started more or less 20 years ago with very simple K9 algorithms. And since then, you know, researchers were able to invent new, more sophisticated techniques, and you know, typically, you know, the most advanced are based on machine learning. So you have linear models like SLIM, you have matrix factorization techniques based on embeddings, you have deep learning techniques, and there's been also a huge improvement when the community starts to change the loss function, and you know, new techniques based on learning to rank. We're able to push forward the quality of recommendations. Okay, and so I was telling you that most of the focus was and is today in top-end recommendation. So since the very beginning, you know, the top-end recommendation was the focus and is still the focus. And I will come to this point almost at the end of the presentation, you know, because one of my view is that one of my opinion why there is no more real progress on the community on this problem is because probably we reached the limit. Maybe we are not able to improve anymore. Okay, it's impossible to have a 100%, I don't know, precision on average precision on this type of problems, because you have a limited information in the data set, a noise in the data set. So, but the community is still focusing a lot on this problem. Okay. And I would say probably because we, you know, the community, I'm talking also for myself, okay, we are in a kind of comfort zone, okay, we know the problem very well, we know all the details, and we have a lot of ideas on how to try to squeeze out a little bit more from this. And so all my discussion today will focus on this same problem. Okay, problem. I call it the classical top-end recommendation problem. Classical means that you know, all these techniques are required as an input what is called the interaction matrix. So a data set where you have the interaction between users, the historical interactions between users, and you can have also eventually some additional side information. But all the techniques we discussed today are collaborative or hybrid techniques that are based on interactions. And as I was telling you before, you know, apparently the community on Rexes has developed a standard for the evaluation, but this standard is not, let's say, black and white, sharp and detailed standard, and so this is one of the main differences between Rexes community and the IIR community. You cannot compare results by looking at different papers. If you want to compare results across two papers in the Rexes community, you have to rerun the experiment. Okay, why? Because now even if, now suppose you adopt a standard which is telling you, okay, you take the data set, you sample, you randomly sample 10% of the interactions for tests. Okay. But there are small details on how you do this sampling, okay, that make the final results impossible to compare. I want to give you a practical example. Now suppose that, so the high-level approach is to remove 10% of the interactions from the data set in order to build your test set. Suppose that by removing one interaction, it could happen that a user has no interactions or an item has no interaction. What do? Do you remove the user or the item from the data set, or you don't remove it? Okay, it's a matter of choice. It's an implementation detail. Okay, but if you do not clearly explain what you do in this specific case, the results, the final results could be totally different. Okay, because if you keep in the data set a user with no interactions or an item with no interactions, you can do it. Okay, this user or this item will not receive recommendations, will reduce your accuracy. Okay, it's not forbidden, I say. It's a matter of being sure about the procedure. Okay. The only way to assess if there is a real progress is to reproduce experiments. And reproducing experiments is a nightmare because you have to re-implement, rerun sophisticated, complex deep learning algorithms. Okay, so it takes time. And we are not the first to highlight that there are problems in the evaluation practices in the Rexis community. There are other works. I'm citing here only probably the oldest one I found. About the lack of rigor, about the lack of shared standards and shared procedures. Okay. I'm coming to to show you some of our results. I would like to tell you that we could we have performed experiments, and the research community should reproduce our work because we could have included errors in our experimental procedures. So we strongly push the community to reproduce our work. And this is something that has been partially done, but we would like the community to do even more. We had a lot of interactions, for instance, with the authors of the paper we tested. Okay? Our results have been, our findings have been at least partially confirmed by independent research works. And there are a number of issues that I told you that the main outcome was very simple. No work was really able to outperform simple baselines. So all the claimed improvements were fake. Okay, I'm using a strong sentence here. Okay, and the reason why this happened, there were several reasons. Okay, and probably the strongest reason was the usage of weak baselines. The authors in these papers were not using strong baselines. Okay, but this was not the only problem. So today I will not talk about the use of weak baselines. Today we talk about the errors we discovered in the code or in the experimental procedures, even on some theoretical assumptions in the papers we analyzed. And another issue we discovered is that only, roughly speaking, 50% of the work we scanned, we were able to reproduce that. Okay, and so for each paper, if the source code was not available, we contacted the authors, we asked for the source code, and so when I mean reproducibility, I'm not simply saying, okay, the source code has to be available online. So we did our best to try to reproduce the publishing. And so roughly speaking, the three main source of errors we found were not necessarily in the order I'm going to tell you now. Theoretical errors. There were some papers were making some assumptions in their deep learning model, and these assumptions had no theoretical enough, were wrong since the beginning, okay? Other papers had errors in the evaluation procedure, okay? Some errors were, let's say, easy to spot, I would say, okay? Other errors were more difficult to spot for us, but also for the authors probably. Another problem was the lack of explicit research questions. Okay? The high-level goal was simply, as in many of these papers, is I want to improve the accuracy. That's it. Okay. But we will see later that we need to be a little bit more specific in our research. So, you know, now I will run through, you know, these problems, the list of problems. I will start from the experimental part, okay, in the evaluation procedure. Probably the most common source of errors we discovered is information leakage. Okay? So information leakage happens whenever during the testing. So the testing is the step in the evaluation procedure when you measure the, say, accuracy of your method, of your algorithm. Okay? And if during the testing you use some information that is supposed to be available only during the testing, but you use this information during the training, okay, this is called information leakage. You are somehow telling to the model already the expected results, okay? And of course the model is aware of the results you expect. As I was telling you, there are two types of information leakages we discovered, some obvious and some more tricky. And so, you know, here are some of the examples. So the first type of error we discovered is an error in the early stopping. So when you use a machine learning or a deep learning approach, very often you do early stopping. What does it mean? In any interactive method, you want to know after how many interactions you want to stop the learning. Okay. So typically you stop until convergence. Okay, but how you define convergence? Okay, what you do is that you take the training set, you extract a validation set from the training set, and you stop your training when your accuracy measure on the validation set is optimal. So you have to stop when you reach the optimum on the validation set, not on the test set. Many works do the early stopping when you have the best accuracy metric on the test set. Some works were even doing so by using different number of epochs for different metrics. So if you want to compute a recall, they were stopping on the test set when the recall was the best. And if you want to compute precision, they were stopping, doing early stopping on the test set when the precision was the best, and for the different cutoffs and so on. You understand that this is a really incredible error of information leakage. And by the way, in all the papers we surveyed, this type of error was present only for the algorithm invented by the authors, not for the baselines. Okay? I'm not saying this was done on purpose. I'm not saying this, okay? Most often, the users, the authors, sorry, were running the baselines pre-trained by the authors of the baselines, okay? So as the training of a baseline is time-consuming, so very often the authors use pre-trained baselines. But this is an error, and as you see, 50% of the works were doing this wrong type of early stopping behavior. A second source of error, and so if you, in this case, if you reproduce the experiment by doing the early stopping not on the test set, which is wrong, but on the validation set, the algorithm proposed in the paper is not performing so well, okay, as compared with the original paper. Another source of error we discovered was the tuning of hyperparameters. Yeah. Yes. No, it's fine. Okay, I will repeat the question for everyone, also for the people connected remotely. How is possible for reviewers to do not spot this type of error? We were able to spot this error because we did a reproducibility work. So we looked at the source code of the algorithm. You cannot spot this error if you simply read the paper, because typically the paper has no time and no space to give you all of these details. So you trust the experimental procedure performed by the researchers. The only way to spot this type of errors is to look at the source code. Currently, okay. One of the conclusions I will tell you is that we should try to push the authors to put more details, also technical details, in the paper, because if you are forced to write technical details, you are also forced to be more rigorous in your procedure. I don't know if I did answer you all. The second type of error we discovered was the tuning of hyperparameters, which was performed again on the test set. The number of epochs is an hyperparameter of a model, okay, but we treated this as a different hyperparameter. But more in general, there were papers suggesting new deep learning algorithms, and the hyperparameters of these deep learning algorithms were tuned on the test set. Again, if you tune the hyperparameters of a model, you have to do this on the validation set. Otherwise, you are overfitting your test set. Okay? By the way, it's important that, very often a young researcher, when you work, all of us, we work under, pressure to publish. And when you write probably the first version of a code, you say, okay, I'm doing this on the test set. I will later fix it and do the tuning on the validation set later on. Probably, the results will not differ too much. You and we should be aware that this is not true. If you have a large number of hyperparameters, you can design a recommended system where you have, an hyperparameter for each user item pair, and you can make a perfect recommended system overfitting the data set. Okay, so the tuning of the hyperparameters must not be performed on the test set. These two type of errors are easy to detect, even for a reviewer, if this information is present in the paper, and also, I would say, by the researcher doing the experiments. But there are other type of errors that are more tricky, even for an experienced researcher to detect. One example is about how to perform the splitting of a data set. Many data sets in the recommended system area, they have a timestamp. So there is a kind of sequential ordering of the events. Even if you are not using the timestamp in your model, what it happens is that if you do a random splitting between training and test set, it could be that you are using for the training some information that happening in the future of the user. So, and again, this is a kind of information leakage. Here, there's an example. This is an example that could happen, for instance, if you're using the movie lens dataset, which contains the Rocky saga, okay? So if you put Rocky 2 in the train set, and the user did like Rocky 2 in the train set, it's easy. And if you have Rocky 1 in the test, it is easy to assume for a model that if you like the Rocky 2, you also like the Rocky 1, because you are asking to predict the past somehow, which is easier than to predict the future. Okay. So this is something more subtle, okay, to detect. And but there is an even more, let's say, tricky example. It's about what we call the sampling of negative interactions. And this is tricky also to explain. And when you evaluate a recommender system, I want to make a very easy experiment, an easy example. Now, suppose you take a user and in the test set, you have only one relevant item for that user. So you want to see how you will rank this relevant item for the user together with a number of non-relevant items. So the common approach should be to rank the relevant test item together with all the other items in the catalog. Okay, so if I want to make recommendations on Amazon, I want to be able to recommend you something which is important for you, compared with all the products in the market, all of them. So when you build a recommender system, you have to evaluate and you have to rank the test item, the test relevant items, together with all the other items not relevant in the catalog. It is time consuming, okay? And as you have to do, if you have to do this evaluation procedure a lot of time for all of the users, and use k-fold cross-validation. So the evaluation step very often is more time consuming than the training of the deep learning algorithm. So in order to speed up the evaluation, it is common to subsample the number of negative items that you use when you rank, when you do the ranking for the evaluation phase. And here I don't have the number. Yes, there are the numbers. So typically, almost all researchers do a sampling of the negative items, and they keep only 10 or up to 1,000 negative items when doing the evaluation. And 60% of the papers do this. The problem is that when you sample the negative interactions, the quality metric that you are obtaining is not the same quality metric as you would have without sampling, not only in terms of absolute value. If you have an algorithm that without sampling is better than another one, if you introduce the sampling, this could not be true anymore. I want to, well, this is something that we discovered with our experiments, but has been confirmed by other researchers. You can find here some papers that, so the sampled version and the unsampled version are not equivalent. Here I want to show you, I don't know if you can see these diagrams from the back, okay? Here you see 5 different algorithms, and on the epsilon, on the vertical dimension, we are measuring the average precision. For each diagram, you have the popularity of the relevant item, okay, from the most popular to the less popular. And each line in a diagram represents a different sampling. The lower one, the blue, is the unsampled evaluation, okay? And if you move toward the upper of each diagram, you have stronger sampling, okay? Can you see how much the sampling is distorted, is changing the evaluation? and the shape. You see, without sampling, so if you evaluate the average precision in this example on the full data set, the average precision for popular items will be on average larger than the average precision on less popular items. If you do sampling, the average precision tends to be equal to, you push the average precision to 1. So you are squeezing everything. You are reducing the differences between algorithms, okay? And so sampling overestimate the real accuracy of a recommender system. Now, I was telling you that this is tricky. I'm not telling you that sampling is wrong. Here, what I would like to tell you is that sampling is different from not sampling. But the research community on RECSYS there is no agreement in the RECSYS community about which approach is the best approach to evaluate the real quality as perceived by a user. Remember, we are doing offline evaluation on historical data set, but a recommender system at the very end is used by a real user. So the only metric that matters is the opinion of the user. These experiments are only approximations of what a user should perceive. And so here, the deeper discussion is it correct to do sampling? To what degree? The community should agree on if and how to use sampling. If not, a researcher can choose the sampling strategy that push his or her own algorithm on top, okay? Because there is no agreement on which is the correct sampling procedure. And okay, I'm skipping things that I already told you. Another problem I was telling you, I lost the notion of time. I don't know. Can you help me in telling me? Ah, sì, grazie. It's 3:30. Okay, so I have to. I have to stop at 4. Alle 4. So I have half an hour. Okay. Okay, you have to listen to me for another half an hour. And so another point is the lack of explicit research questions. So the general problem that is addressed in all of these papers is, okay, I want to improve some accuracy metric. Okay, this is very general. But whenever you know, the experimental conditions that you use in the evaluation procedure affect the relative behavior of different algorithms. So if you compare algorithm A with B, the relative comparison of these two algorithms can be different based on the data set, based on the metric you are using, the cutoff, and if based on the pre-processing you perform on the data set, based on the splitting procedure, okay, based, if you give me any algorithm, okay, I can choose a combination of these that will, in such a way that your algorithm will be the best, okay? I remember there was a nice chapter in the first edition of the RECSYS handbook. I do not remember the name of the authors. They were researchers from Microsoft. They were talking about the hyper-tuning of the experimental conditions. They were telling about this bad practice of, okay, I will choose the experimental conditions that will put my algorithm as the best one, okay, which is a form of overfitting, okay. Now, more practically, this is called somehow the confirmation bias, okay. You are convinced that your approach is the best. You choose some configurations of experimental conditions that prove your bias. And you also find justifications because you are doing this. Okay, you discover that if you pre-process the data set by removing all the users with less than 15 ratings, your algorithm is the best. Okay, and you say, okay, in a real system, it doesn't never happen that you have less than 50 interactions per user. Or maybe you do the opposite. You discover that if in the data set there are users with many interactions, your algorithm is not performing well. So you remove all the users with many interactions, and you say, okay, in a real system, the data set is very sparse, and so my experimental condition is the closest to the reality. Okay. These two extreme and totally different approaches, it could be equally correct or equally wrong. It depends on the research question you're doing. Okay, you need to state an experimental condition, a research question, and define which is the experimental condition that best fit that research question. And in this way, you are able to exactly define the evaluation procedure. So when we analyze our papers, what we found out is that, you know, I don't have here the statistics, but the number of experimental conditions across the 30 papers we did analyze were totally different data sets, different cutoff metrics. I remember one paper that was using NDCC at 100 and recall at 50. Now, I don't want to be, you know, the nasty guy, you know, but why NDCC at 100 and recall at 50? Why not both at 50 or both at 100? Okay. So it's amazing, but there are no two papers that use exactly the same experimental conditions in the 30 that we did survey. Okay. And this is, you know, something that I was telling you, the big difference between the REXIS and the IIR community. In the IIR community, almost all the papers using at least one data set from a track use exactly the standard evaluation procedure as defined by the track. Almost all of the papers. Okay, so in the IIR community, the, let's say, reproducibility is probably much stronger than in the REXIS community, in the specific REXIS community. Another problem we detected is about, again, this is related to the research questions, is the true origin of an improvement in quality. So all of the papers we did survey were papers about sophisticated deep learning techniques. But very often, the authors, to get that sophisticated deep learning technique, they also put some in pipeline, some minor improvements, pre-processing or post-processing of the data, for instance, okay, as part of the algorithmic pipeline. And very often, in the experiments we did, the real gain in quality was not because of the deep learning part, but because of the minor pre or post processing in the pipeline. Okay. And which is the best way to detect this is to implement a proper ablation study. So whenever you design a technique, an algorithm, a method, which is composed by different steps, you need to ask yourself, where is the source of the gain? And you need to analyze each layer in isolation, okay? And eventually, if you discover that, I want to be honest also here. Now, suppose at the end you discover that most of the gain is not on the deep learning approach, but is on the minor improvement, on the minor step, okay, some pre-processing or on some trick. The question I would like to ask to the community, is this simple trick useful for the community? My personal opinion is yes. If you discover something simple that improves the quality, this is worth, my opinion, it is worth to be shared with the community. I don't know how, maybe not in a long paper, I don't know, okay? But it is a positive result, okay? And by the way, once you discover that there is a minor improvement that improves the quality of even a simple baseline, from there on, the community should always use that small improvement in the baseline. I want to make a practical example. As I told you, in our experiments, we did use very simple baselines to compare against the deep learning techniques. And most of the baselines we used were very simple KNN baselines. And in most of the papers, most of the deep learning algorithms were not able to do better than a simple KNN. But what does it mean to implement a simple KNN? Okay. How do you measure the similarity between two vectors with a KNN? You can use cosine, but cosine is not the only metric you can use to measure the similarity between two vectors. There is a wide range of standard similarities. You can use Jacob, you can use dice, okay? So when you implement a KNN baseline, you can do hypertuning on a validation set in order to choose, you have to do this. You have to choose which is the best metric for that specific problem. Okay. You can use other tricks like the shrinkage in order to account for coverage and so on. So there are small tricks that you can use to improve the quality of a simple baseline, okay? And the community should use these tricks when comparing a deep learning strategy or a sophisticated strategy with baselines, okay? And so generally speaking, if you have the Ockham-Razor principle, okay, if you have a simple solution or a sophisticated one, and the quality is more or less the same, I know from the research point of view, and we will discuss later on, okay, about this. It's difficult to have a paper accepted because you propose a simple improvement or of a previous paper. Okay, so there is a kind of pressure toward the design of sophisticated approaches. But if you do algorithmic research, the algorithmic research by definition is practical research. And from the practical point of view, we must prefer simple solutions to sophisticated ones. I also told you about some papers, not many, luckily, having theoretical flaws. Okay? And so some of the papers we did analyze were making some assumptions, but there were errors in these assumptions. And I would like to make a very practical and specific example. There were 3 papers, or maybe more, I don't remember. We discovered 3 of them. Okay. These 3 papers, all of them were published at the PÉREZ. And all of these papers were using CNNs, so convolutional neural networks, in order to, say, improve top-end recommended systems. And the idea was the main idea was, I'm simplifying a little bit, okay? Then if you want, I can drill down. But the idea, CNNs, convolutional neural networks, they make an assumption, okay? You apply CNNs to data, and the assumption is that there is a kind of correlation between neighborhood data. So if you have, for instance, you apply typically CNNs to images, because the pixels, which are neighbors in an image, they are correlated because they typically belong to the same object. Okay? So when you apply CNNs to images or to videos, it makes sense. Okay? And so in these 3 papers, they were applying CNNs to the embeddings of users and items, embeddings that you extract from a data set by using any technique. It could be simple matrix factorization, could be deep learning. Okay. The problem is that the order of embeddings in any embedding-based technique is not relevant. Not in any. There are some embedding techniques in which the ordering of embeddings, it matters, okay? But these are an exceptions and are not the case of the embeddings used by the authors of this book. Okay? So normally, you can change randomly the position of the embeddings in most of the embedding-based methods, and the result, the final result, will not change at all. Okay, so this is an example of a theoretical error. You are applying CNNs to embeddings. So if you apply CNN to embeddings, you are assuming that if two embeddings are close by in a vector, this information has a meaning, but it's not true because you can take apart these embeddings and the final result will not change. Okay, and we did a practical experiment by randomly changing the embeddings, and the quality of the results did not change. So, okay, so this is an example, and so the question is, okay, but if the authors of these three papers published these three papers, is because they were able to prove that their method was able to improve over baselines. How was it possible if the source of gain was not from the CNN? Because of all the other reasons I told you. Okay, I don't remember in these examples which reasons, but there were errors, other errors in these three papers, and because of these errors, there was an apparent improvement over the baseline, but the improvement was not existent, and in this case, it was even possible to understand that the improvement was not possible because of a theoretical wrong assumptions. By the way, a personal note, we submitted the paper to each guy to point this out, and the paper was strongly rejected. So, okay. I don't want to be polemic, but I don't. And this is an example of a not self-healing community, in my opinion, in any case. Okay. From the theoretical point of view, whenever you find an improvement in your experiment, you should always ask yourself, why does it work? Okay. And which part of my sophisticated, complex pipeline was the source of gain? Okay. So try to drill down and ask yourself why. Okay. To understand the reasons. And so what worked is the theoretical understanding, and the why is the ablation style. No, sorry, these are Richard. Okay. And another source of error, and I think I am also at the end of my presentation, another source of error we did find was because of the experiments, the design of the experiments were not in line with the research goal. I told you that we mostly dedicated to top-end recommended systems, but we did also some analysis also on other type of tasks. And an example I want to give you here is about session-based recommended systems. You know, in session-based recommended system, the task is to be able to predict the next interaction of a user within a working session. So the user log in or connect to an online system, the user starts interacting with the system, and you want to predict which is the next action of the user. And so there are many papers that design and evaluate session-based recommended systems by using datasets which are not session-based datasets. One of the most common datasets used for session-based problems is MovieLens. MovieLens is a dataset in which you have the timestamp of movies, but MovieLens has been collected by asking users to rate a movie that the user watched in the past. Okay, so the instant in which the user rated a movie does not correspond to when the user did watch a movie. I don't know if the point is clear, okay? So this type of time information does not reflect an industrial application in which the user, for instance, if you're using Netflix, you click on the description of a movie, then you click on the description on another movie, and so on. This is a session because in real time, the system is monitoring which movie posters, which movie descriptions you're clicking on, okay? And these timestamps are the correct timestamps for a session-based recommender system. So this is an example in which the experimental setting does not reflect your research question, the research goal. And so now that I listed all of the, not all, the issues that we are able to detect, I'm not sure they are all of them, okay? I would like to answer the question, why is this happening, okay? And the first reason, in my opinion, I'm going back to reproducibility, is the lack of reproducibility. Because if the community is, if there's more attention to reproducibility, that means if there are more researchers trying to reproduce other works, it will be easier to spot this error, and there will be more attention when you publish a work in doing everything correct. However, in order to produce a work which is reproducible, and where you, as the researcher, are really careful about all of these details, it's not easy. It is a time-consuming task, okay? And as we are, all of us are, as I was telling you before, we are under this publish or perish pressure, okay? There is little reward for a researcher if you put the source code of your work online with all the details, all the documentation. There is very little reward from the academic community. And so all the system is not pushing researchers in sharing the results and in putting attention to this. And moreover, very often, another reason is that the practical implementation part of a research project is typically carried out by the young researchers that maybe are not so aware about the importance of the details. Think about the information leakage, okay? There are details which are not easy to spot, and the young researcher maybe is not aware of this, of the importance of these details. And moreover, if you publish your source code, there's also a kind of psychological problem, because as soon as you publish your source code with all the details, it could be easier for the community to spot error in your work, okay? So there is, again, a psychological bias to hide information because as we are all working under pressure, we don't want that someone else in the community is going to spot some small detail errors, okay? We're not happy to this is going to happen, but it's normal. It's part of the research activity. It is normal to have errors in a research outcome, and this is how the research communities should have self-heal, okay? We publish research results, some of these results are correct, some of these results contain errors, and the community should help in spotting what is correct and what is not correct. But it's part of the progress. No, cosa sta succedendo? sbagliato frecce, scusate, sorry. So, when from the, of course, the first key message here is if you're a researcher, try to do everything in the proper way. But this is not the solution, okay? The correct answer to this should come from the community. So, for instance, editors of conferences or editors of journals or chairs of conference and so on should try to put in place systems that promote reproducibility papers, that promote publications that do reproducibility works without expecting these works to introduce innovative techniques. And another important aspect, very often, you know, almost all of us, we are nerds. Okay, I am a nerd. So we do like tricky models, okay, sophisticated approaches. Very often, as a researchers, we believe that complexity is equivalent to quality, which is not necessarily the case. So we should try to, again, as a community, as reviewers and editors and chairs, create awareness about the fact that a publication which contribute from the practical point of view to a quality improvement in the state of the art, even if it's not using a fancy method, this publication could be of value. On the contrary, a publication that is using a quite sophisticated and tricky technique, but with an experimental part which is not convincing, maybe is not so useful to the community. The question that you were asking before, how is it possible for reviewers to not spot this? I told you, well, you can spot this type of errors if you look at the source code. Typically, when you set up a reproducibility track, like in CIKM or in Vexis, you ask to some of the reviewers to look at the source code. Okay, this is a huge work. Okay, so even if you set up a reproducibility track, it's not enough because the reviewing effort becomes huge and probably it's not easy. There are thousands of submissions with very sophisticated techniques, and even if we open reproducibility tracks, probably it's not going to be easy to hire reviewers who are able to put a sufficient effort in order to look at the source code, in order to spot these type of errors. Okay, so I do not have an answer to this problem, which is a general problem when you manage publication venue, the lack of resources to check the quality of the submissions. This is a general problem, which is much broader than the specific reproducibility task. And so I'm just keeping some of the suggestions that I already told you before, and some final comments specific to the recommended system community. I'm going back, if you remember, at the very beginning, I told you that I was going back to the top 10 recommendation problem. In the Rexis community, there were some publications about the hypothesis that we already reached the limit in terms of maximum accuracy, maximum quality that you can obtain on the top 10, on the classical, the simple version of the top 10 recommendation task in the Rexis community, at least on the set of data sets that are normally used by the community. So maybe for the Rexis community now it's time to do something else, okay, to move forward to totally different problems or to variants of this same problem, but more difficult, okay? There are plenty of options. But one of my hypotheses that we already reached the limit here. Okay? And so we should do something else. And the final comment here is if the community is self-healing. I was saying yes, at least for some of the communities. I would say no for other communities. When I was reporting the discussion we had with each guy, it's a comment. I don't want to be too much polemic, but when we submitted the work at each guy to spot the theoretical flow of the free papers on CNN, the answer from all of the reviewers was, but the authors of the papers, in their results, they report an improvement. So you must be wrong. Okay. So in my opinion, this means that you do not even think about the possibility that there are errors, that there are wrong results that can pass through the mesh of the reviewing process, okay? And let's say being aware of this and trying to fix this is part of the progress. If you think there are journals where it is normal to have letters where authors, let's say, criticize previous works, there is a very famous case about quantum computing, about a claim done by researchers from Microsoft a couple of years ago about them being able with a number of experiments to prove some quantum supremacy in a set of experiments. And this was published, I don't remember, I think on Nature. And then a number of other researchers were pointing out with a discussion on social networks and then with letters on Nature about the fact that this result was not true. And at the end, the authors of the original paper, they say, okay, there was an error in our evaluation methodology. I say it's not a shame. It's part of the normal progress. And so, thanks. I think I'm more or less in time. And so I'm ready for questions if you have.
Can we make a question from
So I'm not sure I was able to understand anything because with the mask and so on. So we are talking about, can you please repeat without the mask, thanks. Yes. Okay, thanks. I will repeat the question so that also the people, we're not really connected can hear. So the question was, if you work in information retrieval as you are doing, and you have to evaluate an entire pipeline, and which are the best practices or my suggestions on the evaluation procedure if your goal is to evaluate the final pipeline? It depends. Well, my suggestion in any case is to evaluate each single step of the pipeline. If in the type of experiments you are doing, your goal is to, again, improve some classification or accuracy metric at the other end of the pipeline, and you are changing simultaneously different points of the pipeline, you should, again, perform an ablation study and analyze each single effort. I understand that from an evaluation point of view, this increases the complexity. The complexity of the evaluation can explode. But sometimes even a small change that can be, one can think, okay, this change probably will have a minor impact. Maybe this is not the case. So probably depends also on the type of pipeline you are working on. So if some steps on the pipeline are considered a standard in the community, you can forget about that. But if all of them are part of the let's say, approach you're inventing, you should evaluate all of the steps. There is a from Nicola. I know.
Basically, the bottom line is super cool as someone else does. Now this year we have started the artifact magic committee. We launched it for IIR submissions, and we got 5 or 6 volunteers submitted their artifacts. So we have every instrument in place, but the community not reacting. How can we push it?
It's a good question. I have the same problem. I'm trying to push this same, sensibility to reproducibility in the Rexis community. Together with Alan Said, I've been the co-chair of the reproducibility track at Rexis, and I have to say that the response from the community, so the number of submissions we did receive, was much smaller than expected. And I still, and one of the reasons, well, so we're doing something different because in order to have the badge, the author of a paper proposing a novel technique has to, let's say, satisfy a number of requirements in order to obtain the badge. What we are doing is slightly different because we ask authors to submit papers that reproduce previous experiments, but we still have we also have these problems of lack of response from the authors on this, and I think that the reason could be slightly different. In one case is that if you need to perform all the tasks in order to obtain the badge, you need to do a lot of things, and if you think about the usual workflow when you publish a research paper, the line where you have the writing of the paper and so on, maybe you have your code somewhere available, but in a format which is not suitable to be public available because maybe the code is not clear, is full of hacks and tricks and so on. So probably this is not perceived, so the reproducibility badge is not perceived as something important for the career of a researcher. If you have to write a CV, and probably if you have a paper that has been published in a top conference and you also have a reproducibility badge, I'm not sure if this is perceived as something of value in the career of any researcher. I don't know. I've been co-chair of the reproducibility track of CIKM once, a couple of years ago, and I was surprised by the large number of submissions with resource track. Sorry, the resource track, which is, let's say, is slightly different, but it is a track which is pushing somehow towards reproducibility because you share with the community data sets and guidelines and so on. So you're right, is different. But I was surprised by the, let's say, attention that in CIKM was given to this. I mean, the interest. Because one of the reasons of the stagnation I was saying, at least in the Rexis community, for instance, is the lack of data set. Everyone is using the same data sets, okay? The same 4 or 5 data sets. At the very end, you have squeezed everything you can from this data. So there is, you cannot move forward. Okay? So, and having new data sets is not only a matter of, okay, I need a new data set for the same type of problem. We as a community, we need new tasks to solve. I mean, that specific task probably reached its limit. I'm talking about Rexy. You were saying you were having two questions. So.
Yes, basically one thing that we know there are any measures get started these something they say, okay, close it up, prepare it, close it up. While well, assess this, we probably need objective measures to say, okay, this is the
No, your point is an important one, and we have not even started discussing this. So we are, we have to do a lot of steps again to clearly define what does it mean reproducibility. But you're right, and you probably we have to talk about confidence intervals and so on, which makes it even more complex to assess the reproducibility of a work. You're welcome. There is a question here. Oh, also there.
Maybe the only solution then was all stuff and try to scrutinize other words and more young. Of course, there is a risk there that journals make other text to the license.
Yeah.
So probably the best way for those of us who are is to welcome that kind of paper, provided that there is an interaction.
Yes. I totally agree. Sorry, I didn't want to interrupt you.
No, it was just sort of, I mean, the result after the talk is that really most of the papers cannot be many of them are really and really no. So I think as a community, probably the solution push more people to publications.
I agree on this, and from one side, the risk of being overwhelmed by this type probably is not going to be the case too much, because it takes time to reproduce works. But you're right, we need to avoid also to have a Far West where author starts arguing about who is right and who is wrong. And something that happened by chance in our experience was that we were putting the draft of our results on self-archive before and this was a way for the authors. This was not planned, but what was happening is that the authors of the papers with this survey, not all of them, some of them did contact us, trying to understand what was. So they were trying to help us in looking where if there were the problem, if the problem was with our reproducibility activity, because we were, and whenever we reproduce the work of someone else, we we are worried, we are scared, okay? Because when you reproduce the work of another one, you're saying, hey, these results are not in line with what's published. You have a big responsibility. And we are always terrified by doing errors. And you know, this interaction with the authors before the actual submission or the actual publication is a good way in both directions, okay, to be sure that if you reproduce something, you are reproducing it in the proper way, and also for the authors of the reproduced paper to be better aware about eventually issues problems. So, so we should. My high-level idea is to try to do something informal, some kind of interaction, informal interaction between authors of research papers and author of reproducibility papers before the submission, a kind of, you know, two-step approaches, a kind of let's say pre-selection, pre-publishing. I do not have clear ideas on this. No, probably it's not a problem. Different communities, different venues, different communities have different priorities and different goals. So, for instance, artificial intelligence venues, the focus is correctly more on for instance, the architecture of a deep learning approach or some theoretical proof of bounds about some properties of a model, which is fine. And maybe that in this community, there is also an experimental part, which is required or welcome, but is not, let's say, the main innovation for that community, okay? While in other communities which are more application oriented, or maybe within the same community, there are tracks that are more application oriented. And what do you mean? For instance, in Rexes, you do not invent new deep learning techniques. You apply deep learning techniques that have been somehow, or you apply them and you use your hammer to adapt and you know, and so in this community, the goal is more on the final result and not on the technique that you are using. And so in that case, I would say is more a matter of the practical outcome. I would like to make another example, which is not with deep learning. Factorization machines. Factorization machines at the very end are a very first example in the Rexis community about using a technique which is using one-hot encoding to model the input. In my memory, before the deep learning era, the Rexis community started using one-hot encoding with factorization machines, which, and the advantage of, if you ask me, which are the advantage of using factorization machines with respect to other previous techniques, like, you know, matrix factorization or very strange tensor-based approach for context-aware techniques, is the flexibility. Because from the industrial point of view, you write one single algorithm which is able to take into account different type of information, okay, altogether. So it is practical, let's say, and from the industrial point of view, it is elegant from some formal point of view. It is the best, probably not, from the accuracy point of view, okay? But another thing I would like to point out, something that I didn't discuss too much today, is again, I would like to, from a practical point of view. Now, suppose I give you a finite amount of time. I give you 1 week to take a model and produce the best possible results for a given data set or set of data sets. And I give you a finite amount of computational resources. Okay? Now, and you can choose between a KNN model or a very simple model with few hyperparameters, or a sophisticated deep learning model with tons of hyperparameters. If you have a simple model, probably you have more time to fine-tune the hyperparameters to take the best out of your algorithm. Okay. While the sophisticated model will take more time, more computational resources, more effort from your side to be tuned. If you have infinite time, probably, or more time, you can squeeze much more from a sophisticated model than from a simple one. Okay. So another point, which is not easy, is to discuss when a comparison between model A and model B is fair. For instance, think about the tuning of the hyperparameters. In our reproducibility, we choose a policy, which I'm not saying it is the correct policy. We sometimes argue which is not correct. When we tune it, the hyperparameters, we use Bayesian optimization parameters for all the algorithms, the deep learning one and the simple Bayesian. And we use a fixed number of experiments and a fixed number of the epochs for the Bayesian optimizer. Okay. But is it fair? I'm not sure. Because if you are tuning a deep learning algorithm, now suppose we choose, I don't remember, 30 epochs in the Bayesian optimizer. I'm inventing an algorithm. Okay. Now suppose we are using 30 epochs for the Bayesian optimizer. If you do 30 steps with the deep learning algorithm, it takes, I don't know, 2 weeks, because you have to retrain a complex model every time. If you take 40 epochs with a KNN approach, it takes 3 seconds. Even the definition of what is a fair comparison between two techniques is not easy. And this is something that we have to decide as a community. Maybe there will be no one single answer. Maybe there will be multiple answers, or more or less good, okay? And maybe we can put on the table, okay, I don't know, approach number 1, approach number 2. And then when we publish a reproducibility paper, we can state, okay, we have reproduced this work and we have used this comparison by using the evaluation procedure A as defined by the committee, okay, for this committee. So I'm not saying there is only one way, but we have to discuss it. And there are some small details which are not even easy to be aware of. No, you're right. When I was pointing out the problem with the negative sampling, see? Oh, sorry, I will repeat the question. The question was about negative sampling and the fact that negative sampling is widely used in the IIR and access community as a way to, during the training of a model, as a way to control the imbalance between positive and negative samples. Is correct. The problem I was stating that came out in our analysis was about the negative sampling during the testing. And during the testing, what happens is that different techniques or approaches of negative sampling leads to different relative performance of the arguments. So as there is no standard about which negative sampling approach, about if and which negative sampling approach to use during the evaluation, different authors use during the testing different negative sampling techniques, and this makes the performances not, let's say, easy to compare across different publications. Okay.
I have been recommended to be very short, so I will be very short. I try to be easy, so that we can discuss with the break.
Okay.
Thank you very much for your interesting and very important talk, because I believe that several papers that have been published that are not good yet, because they have some flaws. Okay. Those in IIR are very good. I believe that it is a matter of educational responsibility. Even in an era where we are really quick and want to publish a lot, we are very quick in doing reviewers. Okay, all senior people here are reviewers and supervisors of this. So my point is, let's try to change the perspective and state the importance of those. To be accurate, very important to achieve quality of the outcome. So let's start senior people that see our situation, that it is not so important to publish better in a short period, because we hear that it is important to be carefully given and another point, not to be very harsh when reviewing other papers, because this is another point. We are not only to look at the figures of the experiment, because we trust the people who are going to write. Look at this. I will take this small improvement with respect to the experiment in the other paper, without being careful about how the experiments have been conducted. So in a year where we are talking about open science, I believe that the reproducibility will become constant, desiderata to carry out European projects. That's what they ask now, okay, compared to open science. But I want to be very clear on this, as I was saying this. We have to be serious, and we have to tell our students not important. Important to learn, to dedicate the right time to listen and to study the various topics, and to try to do careful experiments, and also to be open to use new model. Maybe we not have perfect experiments, but if you have a very innovative model, it is not possible to follow the experimental paradigm that may be applied when we are in a very known and European task. So, thank you very much. It was more an observation and the invitation to all of us, the beauty of goodness in science. Thank you.
A perfect closing, I would say. I have no comments to add to what you said, so thanks. So, grazie.
Vabbè, Nicola li devo portare. Non solo, per sentirlo qui, bisogna attaccare questo. L'ho fatto già? Sono i primi due? Senti, Claudio, lo so, non ti ricordo.
Appicciamo il nostro computer, connettiamo la rete che manda solo audio. I microfoni possono disattivati. Ok, si prende tutti i microfoni, però devo vedere se c'è tutti i cavi.
No, è un PDF.
Allora, la seconda è
Allora, quando presentano da remoto, bisogna attaccare questo e bisogna alzare ovviamente il volume di questo qui. Ok?
Sì, ma posso dire una cosa? Domenico dove sta? Bravissimo.
Comunque, se fa questa cosa è top, perché ci togliamo tutto il problema perché questo adesso c'è il microfono acceso e poi anche questo dovevamo averlo.
Andiamo a fare una prova.
Verifichiamo subito. Ok, te lo dico subito. Quelli della prima sessione sono già tutti caricati?
Ah, ok.
Comunque adesso li verifichiamo dal vicino.
E poi c'è per caso una stampa del programma?
Certo, certo.
No, in tema non ci sono.
Ok.
Tu presenti adesso?
Lui è session chair.
Ah, scusa.
Presenta tutti.
Ok. Non ci siamo mai conosciuti.
Lucio, Arif.
Sì, ma anche perché, scusa, sì. Perfetto, va bene. Allora, sono tutti qua o sono che persone?
Due. Sono online, il secondo e l'ultimo.
Sì.
Ok. Allora, Anto? Sì, ti sento, dai. Sì, ti metto nella riunione Zoom quando ti connetti. Con che account?
Qual è la scusa?
Claudio. Scusa, i dati della... per poter entrare dalla regia.
Allora, mi cosa scusa?
Allora, aspetta un attimo.
Allora, di caricare una camera di
Devi mettere qua il microfono gelato, lo dobbiamo provare da qui.
Dai, lo mando...
Ma sì, c'è il tuo WhatsApp? Adesso Lucio ti sta mandando i dati di connessione. Claudio sta caricando una presentazione.
Però, anche per voi, cioè che non abbiamo pensato.
Certo. Quale microfono? Il gelato.
Prova. Prova, 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 ho spento il gelato e ho acceso l'altro.
Spegni il microfono anche del computer che sotto.
E non ce la faccio, mi sta dando problemi. Vedi?
No, no, vabbè, basta
Vedi
che...
così. Lo togliamo da Zoom.
basta che è mutato
vedi,
da
adesso
qua.
si è,
Basta che è mutato da qua.
è mutato.
Forse è chiaro. Parla il microfono.
Prova, 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 prova.
Beh,
Non lo so.
andiamo a sentire. Parla.
Prova, prova. Sembra di sì. Aspetta, adesso invece, adesso questi qua funzionano e vanno in streaming. Perfetto. Adesso l'altro problema è quando presentano da remoto, loro si sentiranno ovviamente nel meeting Zoom e li dobbiamo mandare qua sopra. Quindi questo...
C'è qualcuno che lo fa ora?
Sì, il
Qual è
secondo
microfono
è
attivo
l'ultimo.
ora?
Adesso è questo.
Sta qua.
Sa. Se vado, aspetta su Zoom. Sa. Prova. Va benissimo. Se devi attaccare quello, deve stare in muto, Felice.
E poi questo deve essere spento alla fine della domanda.
L'importante è che Felice e il cavo non coesistano, diciamo, questa è la regola. Vabbè, mo fa perché sto vicino al telefono. Felice e cavo non possono stare insieme.
Domanda, spento. Finisci di fare la domanda.
Sa. Sa. Prova. Beh. No, ti dovrebbe succedere il casino, in teoria. Forse sta andando... È perché è basso il volume. Forse perché è basso il volume non fa casino. Prova, mi sentite voi? Prova. Io sento. Ora dobbiamo vedere soltanto se voi sentite l'esterno. Prova. Ciao. Ciao a tutti. Mi sentite? È molto basso il volume, ecco perché. No, questo ora è come se fossi una persona esterna. Ciao. Ok. Sta 1, 2, 3, prova. Sarà questo il volume. Però adesso se accendo questo fa casino. Ciao. Prova. Ma mo sei col cavo attaccato? Prova. No. Prova.
Però così vai a casa, se stai così vicino. Devi. Prova.
Prova, prova. Sì. We are ready to start the first session, the regular session. And first, I want to thank also the organizers, and I'm really happy to be back here also physically, finally, to see many new and all the old faces. And we will start, we have a bunch of talks, we have 8 talks now, and we're starting late, so I will be strict a bit with the time. And we'll start first with the first talk, which title is Measuring the Ranking Quality of Recommendations in a Two-Dimensional Carousel Setting. You're Nicole. Yeah. And NICOLΟ, FELICIONI will give the talk.
Yes. Okay. So, good afternoon, everyone. My name is NICOLò FELICIONI, and I'm going to present a paper called Measuring the Ranking Quality of Recommendations in a Two-Dimensional Carousel Setting. This is joint work with MAURIZIO FERRARI DACREMA, FERNANDO PÉREZ MAURERA, and Paolo Cremonesi from Politecnico di Milano, and content-wise. So first of all, I would like to briefly introduce the classic one-dimensional setting of recommendation systems, where you have, like in the slide, you can see a picture taken from the Amazon website, where you have a classic one-dimensional list with recommendations. And in this case, the objective of the recommender system is to provide the items that are relevant to the user, so to provide them inside the list. And also another objective is to make that the most relevant items for the users are in the first positions of the list, so that the user will not have to skim through the list in order to find the relevant ones. So these two assumptions, the fact that highly relevant results should be displayed to the users and the fact that highly relevant results should be in the first positions of the ranked list, are the base of one of the most used metrics in information retrieval and also in recommendation systems, which is discounted cumulative gain, or DCG, and its normalized version that is called NDCG. Following, where we have a summation of all the items inside the list, where the numerator will have to reward relevant results, while instead the denominator, which is a logarithm with the position inside the logarithm, will penalize the items on the bottom of the list. So it will reflect the two assumptions we just discussed. But now I want to present the carousel layout, which is a different type of layout that it's typically found in real case scenarios. In fact, you can see in the slide an example taken from Netflix, which I think everybody used in this room. But it's also typically found also in, I don't know, Spotify, Prime Video, and a lot of services like that. And in this case, we do not have a single one-dimensional list, but instead we have multiple lists, which we call carousels. And we can also swipe through the list in order to reveal further items. And we can also vertically swipe the interface in order to reveal further carousels. So if we want to apply, basically only adapt the DCG metric on this scenario, we make a strong assumption that user exploration is one carousel at a time, and it's from left to right. But this interpretation can have several issues in this two-dimensional scenario. because, for example, it does not take into account the golden triangle effect that you can see on the slide. The golden triangle effect is an effect first found in the information retrieval domain, and it says that if you take into consideration the 2 dimensions of an interface, you can see that the gaze of the user, the focus of the user, will go on the top left corner. Also, there is the fact that different carousels may provide the same recommendations, and so there is the duplicate, and this was impossible in one single list, because in a single list you don't have the same recommendation 2 times. But instead, if you have multiple carousels, you can have the same recommendations, because sometimes carousels are provided by different providers and you don't want to post-process them, and so there may be duplicates. And the third issue is the fact that there may be swipes to perform. So in the slide, you can see a heat map of the impressions taken from a data set released by ContentWise. And so you can see that in the middle of this heat map, there is a strong demarcation line where the left items have more impressions than the right items. And that's because there is a horizontal swipe to perform in order to reveal them. So they are less seen by the users. Thus, inspired by the DCG, we wanted also to make some assumptions relative to this type of scenario. First, we say that highly relevant results are valuable for a user, but this is exactly the same assumption for the DCG. Then we say that our result is really relevant only when it is first seen. So the duplicates are not relevant in our evaluation. Third, we say that within a grid of results, we want to reward the top left corner and penalize the bottom right corner. And lastly, we want to penalize the user swipes. So if you have to perform user swipe horizontally or horizontal vertical swipes in order to reveal an item, this should be penalized. So this is our general formulation for a metric that reflects those assumptions. We call that 2DCG, and it's a double summation on the 2 dimensions of the interface of a gain function times a discount function, and we will see how we define those 2 functions. So the gain function is basically the same as in the one-dimensional version. And this will basically reward the highly relevant results, while the discount function will depend on the layout we have in our real case scenario. So let's see the discount function in details. First, we say that there are some weights that we can tune for the problem that we have, and we call them alpha, beta, gamma, and lambda. Then we see the general structure. You can see that it's 1 over logarithm, exactly like in the one-dimensional case. And now we will see what's inside of this logarithm. So the first term will penalize the item on the bottom right corner, because alpha times I plus beta times j will be larger when the coordinates of I and j will be at the bottom right corner. So this is a penalization that will take into account the golden triangle assumption. And then we just define 2 functions. There are number of vertical swipes and number of horizontal swipes that will take into account the swipes performed. So in this case, we want to penalize the swipes in order to reveal the item. For the experiments, we decided to make a comparison of the NDCG and the N2DCG, so our 2DCG in a normalized way. And we took the movie lens 10 million dataset, a very widely used dataset in the recommendation system research. We decided that in our scenario, each carousel is composed by a different model. So every recommender systems model will provide us a carousel of recommendations. And in order to choose which recommender models to take, we decided to train and tune a wide set of recommender models, from k-nearest neighbors to machine learning ones. We decided to have this hypothetical interface with a total of 6 carousels. We decided that each carousel has 10 items. We placed we set every weight equal to 1 just for simplicity, but we say that if you have a particular scenario, you should tune those weights for the problem at hand. And the UI is like in figure. So you can see that it's a more vertical scenario, typical of the mobile scenario, where you have 3 carousels that are initially shown. And for each carousel, there are 2 items initially shown. So in order to compare these 2 metrics, we decided to run this greedy algorithm. So we wanted to optimize an accuracy metric value and to build a layout of 6 carousels. So we decided to first select and fix the carousel with the highest metric value among the one provided by the recommender models. Then for the other carousels, we decided to take the carousel that has the fixed the previous iterations of the algorithm. So in the end, we built the layout with the 6 carousels selected, and we repeated this, first optimizing the NDCG, and then optimizing the N2 DCG. And the results are those you can see on the slide. So in bold, we highlighted the differences of the layouts. So there are some differences in the 2 layouts we obtained, but this does not mean that one metric is better than the other. This was not the goal of the paper, but instead we wanted just to highlight the fact that the 2-dimensional interpretation we took can change the relative evaluation of layouts. So if we want to optimize the NDCG, it's fine, and the best layout is the one on the left. But if we have a 2-dimensional layout, probably the better layout is the one on the right. So to conclude, we say that in our paper we highlighted the problems with applying, just basically adapting a standard 1-dimensional metric to a scenario that can be a carousel scenario, but more generally a 2-dimensional scenario. And so we propose a novel 2-dimensional metric. And the experiment, as I said, basically can show how the 2-dimensional interpretation may change relative evaluation of the optimal, what we can call optimal layout. And so in the end, we claim that if you have a 2-dimensional interface, you probably should use 2-dimensional metrics, or you should take account of the 2-dimensional layout. Thanks for the attention.
Thanks, NICOLÒ. Okay. Any questions? Yep.
Okay, it's not.
Can you repeat the question?
Yeah, he said that I did not get why the carousels optimized with my metric is better than the other layout. I did not say that it's better, but I just wanted to show that it is different, because in our metric we take into account the fact that in our hypothetical layout there are some swipes, for example, to take. So like if you see the layout, the hypothetical layout on the slide, our metric basically can penalize a lot the 3rd item of the first carousel, for example, because there is a horizontal swipe to perform, when instead the NDCG will not. So if you have actually this is just hypothetical, but if you have an interface like that, probably it will change the evaluation of layouts. So it's just a different way of evaluating the layouts.
So
like in platforms like Spotify or Netflix, I always notice that these carousels, they all have different motivations, like things that new movies or things that you watched before. You see like the motivation of each horizontal line is different. So how do you incorporate this in the relativeness? Like, I would say the assessment, the judgment of this relatedness of these items being in different carousels should be different to the user.
Oh yeah, I see. Yeah, I don't know. Actually, this maybe relates to the fact that you should reward less accuracy and more diversity. I don't know, because when you have you have actually some constraints when you build a carousel layout, because the rows, as you pointed out, must be thematically coherent. So in this case, you have a row called TV comedies and another row called new releases. But in our case, we just evaluate the whole page. So how the user can be, how the user finds the whole page in all. But you say something that is true, so that if you have TV comedies and the user doesn't like TV comedies, it's not you can not do anything about it. And that's probably the fact that you should place another carousel on top, probably. So it's another type of problem, how to place carousels in order to optimize the layout.
This is also related to thinking about each carousel as a whole can be also be evaluated, right?
Yeah.
So if the user doesn't like any comedies, being on the top carousel is a very bad thing in terms of evaluation.
Yeah, exactly. Yeah, and that's true.
Okay, thanks, NICOLÒ.
Thank you.
The second talk is going to be online.
Yes, can you hear me?
Presented by, I think, NOEMI MAURO, and the title is Holistic Summarization of Recommender System Results.
Hello, can you hear me? Can you hear me?
Filippo, we hear you,
Yes.
but we don't see the screen.
Okay. Now.
Yeah.
Okay. I don't know if also in Bari they can hear me or not.
They say they can hear you, so I think you can start.
Okay, thank you. So, hello. I'm ZHONGLI Filippo, PhD student from University of Torino. Here with me, we have in virtual presence NOEMI MAURO and LILIANA ARDISSONO. Today, I'll talk about an holistic summarization of recommender system results. First of all, let me give you a short introduction of the topic. In item recommendation, one of the main obstacles to the decision making that the user need to do to decide which item buy or rent is understanding why items are relevant. The system can give some information to the user to help this process and to increase awareness and transparency. So we have two ways to give more information to the user. The first one is explanation. We explain why an item is suggested, and often this is based on the recommendation algorithm, and this could be hard. And a second way is justification. The items is justified post hoc based way, and it isn't based on the algorithm. It is so more general, and it can be generated using features or user feedback. This could lead to partial views to item or very long description. So there is a need to support the overview of item recommended in order to help the user quickly identify the relevant items. We are focusing in our work in experience items. Item evaluation in this case is more than the appreciation of its local properties. We can consider the entire user experience during item fruition. So we can use a service description to generate an overview of user experience in all the phases of item fruition. Service journey map support the development of online services by focusing on how user experience them. It is a visual description of a service which models the various stages a person do during the item fruition. So the goal of this work is the generation of a service-based justification overview to summarize user experience with item. In the home booking domain, in our previous work, we identified the following steps of item fruition in this service journey map. First of all, we have a typical user visit the website of the service and rent the home. Then there is the check-in, the stay in apartment, and the checkout. We identified the related dimension for item evaluation. Our evaluation dimension we found in this process, so is this 5. We used apartment monitoring, a platform that supports the exploration of homes. The dataset is retrieved from Airbnb. In this interface, we have a scrollable list that of suggested home with a graphical overview and a star-based home evaluation. In this view poorly summarizes user experience and doesn't communicate enough about each dimension. So our proposal is to replace the star-based feedback into bar graph that give more information about each dimension. So in order to test this model, we created a reduced and limited application with our wizard model we propose with only some part of the view, because we want to focus on bar graphs. In fact, we use bar graph that summarize previous guest reviews under service journey map dimensions. We want to investigate these factors. The bar graph helps the user to quickly assess the previous guest feedback, and if the visual model support the decision making, or user need to view more details to choose a home to rent. We conduct a preliminary test with the live user with this task. We asked to rate 5 homes with only the bar graph dimensions. We asked if the homes were a good candidate to rent, commenting with a think aloud protocol, and we gave the possibility to vote the opting out option. We decided to hide amenities pictures in order to force the participant make their choice on the basis of the data we provided in our model. Now I present the result of this preliminary test. About the questionnaire, the 12% of the ratings were the opting out value, I don't know. So they didn't evaluate the homes. About the think aloud protocol, two people said the bar graph is useful to filter out bad homes. Moreover, the visual model supports information filtering, but it is not enough to feel confident in booking a home. 3 people say they used host appreciation and didn't consider home with low host appreciation. So some dimensions are more important and useful than others for filtering. And 3 people say they don't care about values on the bar. So, but they compare the bars each other to see the best or the worst dimensions. So we described a visual model aimed at summarizing customer experience with items. This preliminary test helped us to understand that our model is an efficacious support to information filtering, and so helps to filter out badly performing homes. In the future, we plan to extend the bar graph describing customer experience with on-demand qualitative data supporting the evaluation they express, and with dynamic selection of aspects of summarization. And we plan to conduct a larger user study testing different graphical approaches. Thank you.
A quick question. A quick question. How many people were in the user study?
11 people is a preliminary study.
No.
Sorry, I didn't get.
Repeat again, please.
I didn't get the.
Maybe can you type the question in the chat, because we don't hear anything.
Okay, the user study was conducted with 11 people, and because it was a preliminary test, and we plan to conduct a larger user study.
Yeah, actually, if I can say a bit more, we already carried out a larger user study that included about 50 people. And so the work is going on, and this made it possible to acquire more precise results than this initial one that was just a first idea to check the bars and their value in summarizing experience. So maybe we can say that the larger one basically confirms the impressions we got in the one that Filippo just presented. But of course, it provided much more information to us because it was more articulated and whatever. But yeah, it is not published yet.
have 6 more talks, short talks, of which are by NAIEME HAZRATI, entitled "The Quality and Diversity of Recommender Systems Users' Choices, Simulation Perspective."
So,
PDF.
yeah, it's a PDF.
Ah, right. Okay.
Okay, perfect. Okay, hello everyone. Good evening, good afternoon. My name is NAIEME HAZRATI and I'm a PhD student at the Free University of Bolzano. My supervisor is Professor Francesco Ricci. And now I'm going to present a simulation framework that is meant to be used in order to investigate the effect of recommender systems on the evolution of users' choice behaviors. So typically the procedure of putting a recommender system into production comes in 3 steps. First of all, you run an offline evaluation and you see how your method works offline with measures such as accuracy measures and also ranking measures. And then if you get results that are not too bad, you put it for online evaluation, you do some A/B tests and you see if your click-through rate is good. And finally, if you get acceptable and promising results on these 2 tests, you put it for production. So these 2 tests, they give a lot of information on the efficiency and the performance of your recommender system, but they still miss a lot of other information. For instance, offline evaluation, it evaluates, these methods, they evaluate the recommender systems recommendations and not the choices that the user makes when facing recommendations. And on the other hand, online evaluations, they are usually put for a short period of time and you cannot see the long-term or even short-term effect of a recommender system on the behavior of users. So we should consider also that a recommender system can affect users' choices in long term. So simulations, they can cover some of the limitations that these 2 tests have. So if you can model a user's choice, you can also model the repeated choices of a collection of users. And in this simulated environment, you can just analyze users, these simulated choices, and then you can see how these choices are evolving, how the distribution of the choices are changing over time. So this is what we do in this work. We simulate an environment of users and items where users are making choices over one after another. But we also assume that there are alternative recommender systems that can influence an individual's choice before she makes the choice. So I will present the schema of the simulation. So in this simulation, users make choices based on a choice model, a multinomial logic choice model, where the utility in this choice model is relevant to the predicted rating of user item pairs. So we have the full rating matrix. Some of them are predicted. And then the users make choices based on this utility function. However, a user cannot choose from the entire catalog of items. A user is assumed to choose from a set called the awareness set, a smaller set that represents the knowledge of the user about the catalog. And after the awareness set is built, the recommender system recommends a set of items to the user, and these items are added to the awareness set, and plus the utility of these items are artificial to the recommendations. So to conduct these simulations, we have chosen 3 timestamp datasets of ratings from Amazon, and we brought this data into time intervals, which is months in our case. It can be different. And then these choices are simulated within time intervals, one after another. And then we have also alternative recommender systems. We have different scenarios, one recommender in each. And these recommender systems are trained on the real and also simulated choices. And after each time interval is finished, the recommender system is retrained on the simulated choices of that interval month. And we simulate 5 recommender systems, 3 personalized collaborative filtering recommenders, and also 2 non-personalized popularity-based and average rating-based. We also simulate a scenario where there is no recommender system. And now I will show you the results. We have measured various metrics on the choices. And you can see in these figures that the x-axis shows the month, the interval, and you can see the evolution of the metric on the y-axis. So here I brought the Gini index, a measure of diversity. So Gini index measures, Gini index is relevant to the opposite of diversity. Higher Gini values represent lower choice diversity. So you can see here that the non-personalized recommender systems here, you can see that they produce a higher Gini values, which means lower diversity, which is understandable and trivial because they recommend the same set of items to all of the users. But this is the same in all of the data sets in apps, games, and Kindle. So, however, you can see here, if you compare the orange, the scenario where there is no recommender systems, and compare it with LPCF, the red curve, you can see that in the apps data set, LPCF is producing a higher Gini compared to no recommender system. Which means a lower diversity compared to the case where there is no recommender. But in another data set, in games data set, it's the opposite. LPCF is producing a lower Gini, higher diversity compared to the no recommender system case. So here we can conclude that the data set plays an important role in the effect of the recommender system on the choices. And it is important to conduct simulations on a data set before actually, based on a system, before actually deploying that recommender system to your environment. And I will explain one other metric. This is the choices rating, the predicted rating of the simulated choices month by month. And this shows that, surprisingly, the non-personalized recommender systems are producing a higher choice rating, which is not what we have seen in the classical evaluation of recommender system. And this is another interesting results that we have obtained. And okay, now I move on to conclusions. We have designed a simulation framework that is based on the data set, based on real data sets, and we have obtained various interesting results that are that I have presented some of the results, but there is still a lot to do. We still have to predict the number of choices made by each user at each time interval, and we also need to assume that a user can make repeated choices. These are the assumptions that we have not considered in the previous, in this work that I presented. And the work that we have done, the full version of this work is submitted to the Journal of Information Processing and Management, and it's currently under review. And yeah, that's it.
Thanks.
Thank you.
So if you have any quick question. Okay. Very quick.
How do you think that the limitations that you highlighted may affect the result that you presented?
Which one?
In the previous slide, if you show the previous slide, yeah. So you have these two limitations here, right?
Yes.
So how do you think that this limitation may affect the takeaway message that you
So if you want to consider, for instance, repeated choices in your simulation, you have to adapt and you have to constrain these repeated choices in any case. But if the number of choices are, I think if the number of choices are high, it's not going to change a lot using all of the always the same item. So this is we have put this constraint because we were having data sets of books, applications, and video games. So it makes sense in these domains, but in music domain you can always change your assumptions. And then on the number of choices, I think it will not change a lot because the prediction of the number of choices, it's not really difficult. I mean, it is very difficult, but the prediction of it's not going to change a lot the evolution of the choices because you consider the aggregate behavior of the users, and you're not doing it individually. So if you predict the number of choices, it's not going to change the aggregated measures a lot. Thank you.
Okay, next we have Claudio Pomo, I think, who will talk, and we have a long title, but it's a talk that will make Paolo happy. It's about reproducibility in recommendations. So, let's see.
Hello, everyone. Good afternoon. I'm Claudio Pomo, PhD student from Politecnico di Bari. And now I'm glad to present you our work, how to perform reproducible experiments in the Elliott recommendation framework, data processing, model selection, and performance evaluation. I start by presenting the outline of this presentation. I will introduce and motivate our work. Then I will present you our framework, Elliott, and in the end, I'll draw some conclusion and detail some feature works. Recently, recommender system attracted a lot of interest, both from academia and industry, and it's widely applied in various domains, such as multimedia recommendation, e-commerce, or point of interest. And for this reason, nowadays, we have an impressive number of recommendation algorithms applied in this area of interest. By the way, we have a problem about the evaluation of these algorithms because we don't have a standard benchmarks to evaluate this model. And in their work, FERRARI, DACREMA, Cremonesi, Boglio, and Yannack expose very well and deeply investigate this aspect. And they prove that there are some methodological issues related to the choice of the baseline, the propagation of this weak baseline when we compare to the other models, and the lack of proper tuning of this baseline. Moreover, in their recently publication about reproducibility, Belloghin and Said pose some guideline and best practice to address these issues, because there are two major concerns. One is related to the unfair reproducibility, and the other one is related to the impossible to compare properly this model. This issue and bad habits have promoted us to rigorously investigate aspects of the reproducibility for the recommender system scenario. And this effort is promoted our building of a new flexible recommendation framework, Elliot. And this framework is driven by a simple and only one configuration file. Elliot helps the researcher when a researcher wants to implement a new splitting strategy, testing properly a model trained and optimize the hyperparameter model, and in the end generate the final results and experimental marks. To enhance the reproducibility and facilitate a fair comparison between different works, we have highlighting 5 different stages: data splitting, item recommendation, candidate item generation, performance measurement, and statistical testing. With respect to the other open source framework for recommender system, such as MediaLite, which primarily try to replicate the state of in different way the entire pipeline of a recommender system experiment, because we want to build with a single configuration file the entire pipeline. This is a landscape of our recommender framework with 8 functional modules, from data filtering to recommendation part. But we detail this module in the following. Now I will show a simple configuration file that drive our recommendation framework. As you can see, there are 4 parts. One is dedicated to the data handling. The second part in green is dedicated to the models that are involved in the experiment. Then in the light green, we have the evaluation part, in which we indicate the metrics to investigate. And in the end, we have the output part that responsible to store the results and to provide us the final marks of our experiment. Okay, now we explore each module. The data preparation module is responsible for handling and managing the experimental input, and there are 3 main features that compose it. The loading stage, that is responsible to handling user item interaction and the side information, such as item feature. The prefiltering part, that is responsible to drop out some user item interaction based on threshold or on a key core strategies, but each researcher can implement its own strategies to this stage. And in the same way, we have the splitting part that is responsible to split in train, test, and validation the user item interaction. And we have implemented 3 main families of strategies: time-aware, k-fold validation, and k-random subsampling. As you can see in this slide, our framework covers the measure of this feature, both for prefiltering and splitting, with respect to the other competitive framework available online. Then we have the recommendation model part. In this module, we provide the functionalities to train or to restore the Elliot recommendation model. Actually, Elliot implements more than 15 baseline, from unpersonalized to autoencoders model, without neglecting latent factor model or neural network based, but each researcher can implement its own model and test it with the other baseline. As you can see in this slide, our framework is very competitive to the other in terms of number of baseline exposed, from the standard to the most recently baseline and models provided by the community. Alongside with the model part, we have the hyperparameter tuning. And this stage is very important because, as we mentioned in the introduction, this is one of the methodological issues that emerged from the previous study. Elliot provides different strategies to explore the hyperparameter, from the standard grid search to Bayesian optimization, different strategies to identify the space to explore, and in the end, also the number of trials for each kind of these hyperparameter to test our model. At the end of this stage, Elliot provides the best model on this kind of data and use this model and compare it to the other models involved in the experiment. The evaluation performance part is responsible to measure the characteristics of the metrics that we are try to understand in our experiment. We exposed 36 evaluation metrics belonging to different families, and we also introduce, and Elliot is the one framework available online that is able to measure metrics belonging to bias and fairness family. As you can see in the next slide, we have the only one that provides this kind of metrics, but we also provide the possibility to perform statistical tests because we want to know if the results that we obtain is statistically significant with respect to the other baseline involved in our experiment. And also in this case, Elliot is the only one framework that obviously in the end, Elliot provides the possibility to store the results, to store the weights of each model, and also to store the recommendation list. And in the end, also Elliot provides also the JSON file that summarizes the best model involved in the experiment. Best model for each the models that are optimized during the exploration of hyperparameter. So to conclude, Elliot is a framework that sustains researcher in recommender system, and we review systematic the recommender system evaluation literature and positioning Elliot among this existing framework. We plan to extend, obviously, this framework in various directions, such as sequential recommendation or sample evaluation. Thank you.
Thank you, Claudio. We don't have time for questions, so we can continue with the next
Thank you.
talk. Yeah, thanks. Andrea Iovine, who will talk about the impact of natural language on conversational recommendations. Okay, right. Good evening, I'm Andrea Iovine. I'm a PhD student from the University of Bari, and today we'll present our work, which is titled An Investigation on the Impact of Natural Language on Conversational Recommendations. The objective of this work is to introduce natural language interaction into a conversational recommender system and evaluate its impact on both recommendation accuracy and interaction cost. For this purpose, we have developed Converse, which is a domain-independent framework for the creation of conversational recommender systems that interact with via text dialogues. Converse can understand users' preferences, recommend items, and explain them based on the user's profile, and can also adapt its behavior depending on the feedback that is received by users. Converse has also been implemented as a Telegram chatbot. Interaction with Converse follows 3 steps, the first of which is talk about the items and the properties that they like or dislike. So, for example, movies, directors, actors, or genres. This step is largely user-driven, as the user has all the control on which preferences are expressed to the system. After enough preferences are collected, users can request a set of recommendations. Also on request, users can ask about more details about the recommended item and for an explanation about why a certain item has been recommended. Also, users have the ability to give additional feedback to each of the recommended items. So an adaptive strategy is used by Converse in order to integrate this feedback into the user profile and improve the subsequent recommendations. As for the architecture, Converse uses 3 main components, the first of which is natural language understanding, which is taught with understanding the user's utterance, which this involves capturing the intent of the message, so the request or the action that is expressed inside the utterance, the entity recognition, which means extracting the mentions to entities that are expressed in the message, and sentiment analysis, which is extracting the sentiment that is associated to each entity in the message. The dialogue manager component is instead tasked with maintaining the conversation between the user and the system. And this involves keeping and updating the state of the dialogue, so all the information that is exchanged between the user and the system, selecting the most appropriate action to perform depending on the user input and the dialogue state, and generating a textual feedback that will be written back to the user once the action has been performed. As for the recommendation algorithm, Converse uses a graph-based algorithm, in particular the PageRank with priors. It also exploits a knowledge graph that is being extracted from Wikidata. This component also features an explanation engine that is able to explain why an item has been recommended by finding connections between the items in the user profile and the current recommended item inside the aforementioned knowledge graph. So the objective of the experiment, so we performed a user experiment in order to compare 3 different ways in which we can interact with a conversational recommender system. The first one is natural language, which is in which users can only interact with the system using text messages, and which features a user-driven profile elicitation as we described earlier. Second, we use a more traditional button-based interaction mode, which features instead a system-driven profile elicitation in which the system proposes item to rate and users can only respond to these messages by pressing buttons. We also added a third configuration, which is an extension of the natural language interface, but that assists users by proposing specific context-sensitive buttons in certain parts of the interaction. For example, when there is a need for resolving ambiguities in the natural language text. So for this reason, we have performed a within subject user experiment which involved 159 participants, which were divided into 3 domains, which are movies, books, and music. During the experiment, the participants had to perform all 3 interaction steps that we performed earlier. So they first rated at least 3 items. Then they received a set of 5 recommended items for each domain. And finally, they had to give feedback to each of the items that were recommended by the system. So the objective of this study, of this experiment, is to basically understand whether natural language can improve a conversation recommender system, both in terms of cost of interaction and in terms of quality of the recommendations. So from the experiment, we can see that both natural language and mixed interaction modes were able to ask less . On the other hand, however, we can see that the natural language only interface for users require more time to complete the task with the traditional, with the natural language only mode compared to the button-based interface. On the other hand, however, the mixed interface was able to significantly reduce the time needed to complete the task compared to both interfaces. In terms of quality of the recommendations, we can say that the mixed interaction mode was able to improve the quality of the recommendations, not only in terms of accuracy of the recommended items, but also in terms of the quality of the ranking of the items as measured by the mean average precision metric. So, in conclusion, we can say that even though we may assume that natural language interaction alone can be indeed beneficial to conversational recommender systems, there are still some challenges in the interaction, and these challenges are mostly prevalent when the ambiguity of natural language arises. So, for example, when a user needs to select one option from a limited set of options, this can become cumbersome to users, especially when they need to specifically type a certain option. By introducing the ability of assisting users via buttons in these particular moments of the interaction, we are able to overcome these issues. And as a result, we can say that the user experience is improved, but also the quality of the recommendations is improved. So these findings are actually the results of a work that was published in 2020 in the Decision Support Systems journal. So thank you for your attention.
Thanks, Andrea. Yeah, let's thank Andrea, and maybe there's any quick question while Felice prepares for the next talk. Yeah, Felice, can you prepare in the meanwhile?
There are many cases in which this mixed approach is not possible. So, how do you?
So when we have performed this experiment, most of basically the interface that we used was mainly a text-based one. So we were working basically with a smartphone interface where we do have a keyboard, but we also have the ability to press buttons. So this is a kind of a different problem. In fact, this is a problem that we can face in case of voice-based systems. So in these cases where we don't have actually the ability to type, but we only have the voice. So this is a bit trickier. I guess there may be some ways to solve this. There are maybe analogous solutions to this. Instead of having buttons, maybe the system could facilitate the ability to select one of different options by maybe saying, I don't know, maybe option 1 or option 2. Maybe saying 1 or 2 may be easier to understand compared to maybe having to
after the name of a thing, or yes, this is probably the easiest way to do this. Maybe also the least interesting one, but I'm sure that there is kind of research in voice-based systems about this particular issue.
Okay, thanks. Thank you. And next we have Felice Antonio Merra.
Hi everybody. Okay, I can start. Yes. Okay, I'm presenting the work a regression framework to interpret the robustness of recommender system against shilling attacks. This work is focused on recommender system. Recommender system are used in nowadays platform to support users in the personalized decision-making process to simplify their lives. Recommender systems are based on different factors like content-based one, so based on historical data. Collaborative information means that what are doing other people is useful to others one. So to recommend, for instance, to Julia, what John, Sam, and Pino have saw or bought before. For this reason, this type of collaborative-based recommender system can be attacked by possible adversaries by adding fake profiles, so fake users or fake accounts that start to behave in a malicious way. What is the goal? The goal is to get personal gains against competitor on an e-commerce platform or market penetration, or also to reduce the trustworthiness or integrity for an online platform. And while prior research has been focused on the design of attacks or defense algorithms, or also detection strategies to identify possible fake profiles, we have found a lack to try to understand which are possible reasons for the robustness of the system. So given popular shilling attack strategies and classical collaborative filtering models, we try to answer the research question, trying to explain if dataset characteristics can have an impact on the robustness of collaborative filtering models. So what we have done basically is to identify possible independent variables and dependent variables in a regression-based frameworks. As for the independent variables, after a study of the literature, we have identified that possible structural, distributional, and value-based characteristics would have influenced the effect of attacks. So we have started from studying the space size, the shape, and the density of a data set. Then we have studied also the Gini index, where when it is 0, it means equal popularity. So all users give the same number of ratings, while once is total inequality. So one user give all the ratings. And for value-based, we use the standard deviation of the ratings in an explicit-based dataset. While for the dependent variable of these models, we have choose the incremental overall iteration. So in this way, we would be able, for us, it is possible to measure if a target item, the items under attack, has been pushed in higher position. So we basically measure the iteration before and after the attack for a specific target items. And the explanatory regression-based framework that we use is used to try to answer the question, are these dataset characteristics causing this variation in attacks performance? And while this is the basic formulation of the model, it is important to analyze here that what we will go to analyze are the coefficients that we are going to learn with this type of setting. So theta D and theta C are the coefficients that on which we are going to study the directionality and also the statistical significance. To this, in this work, we have tested 3 common datasets in the item recommendation task, which are Movements 20M, Yelp, and the Last FM with 1 billion of recorded feedback, 125 billion recorded feedback. While for the recommender models, we have started from very basic but also very effective one, like user canon, item canon, and a simple matrix factorization approach. Coming back to how we build the fake profile, basically we have to select some items, the selected items, it's a name with a specific characteristic that comes from a particular knowledge on the dataset or on the models. And then we have to select the target item, the last one, that is the item that we are trying to push or nuke in the recommendation list. While IF are items generally selected randomly to mimic a normal behavior of the user. These are the 6 attacks that we have tested in this work, from a very simple without knowledge one, which is the random attack, to a very difficult attack with perfect knowledge on the data and the recommender models. Before going to the analysis and the discussion of the results, what we will take in consideration are the coefficient of determination that explain how much the dependent variable has been explained by the independent variable, the directionality, and the significance of the regression coefficient. And this is a snapshot of the experiment. What we have seen is that with these 6 independent variables, we were able to explain at least the 60% of the values, so a regression coefficient higher than 0.6. And for instance, in the case of Yelp, but you cannot see this because it is here, we have also value higher than 85 or even 90%. So it is quite effective, this set of independent variables. The message from the analysis of the significance is that the structural characteristics have a statistical significant or even not significant for the standard deviation. So we're focusing our attention on the directionality of the structure. We can see that density and space may have a negative impact. It means that increasing the density or decreasing the sparsity of the dataset, it will reduce the attack effectiveness. So in this way, we are improving the robustness of the model by adding, for instance, also some particular new ratings, while the shape has a positive impact, so in the opposite direction. So increasing this shape, the shape will increase the effectiveness of the attack. We have also conducted the analysis trying to put together all the experiment across the 3 data set, and the results are also consistent when we use one single regression model for all the data set. So let's conclude this presentation. We have studied possible impact of dataset characteristics. We have shown global and local analysis on this framework, and our intention is to extend with deep learning models, more complex type of attacks like adversarial based attacks, but also other dataset characteristics. So there are different dimensions that we can continue to explore. Thank you.
Quick question while the next speaker is also coming. Okay, thanks again. And the next speaker is Paolo Tenti, whose talk is using an ensemble of features for personalized recommendations of scientific publications. Fai, lo riconosci? Vedo poco. Ah. Beh, la prendiamo dal... No, non va bene questo.
No, perché poi non lo può girare. Questo qua, attenti. Ok. Perfetto.
Hello, I'm Paolo Tenti. I'm a PhD student from the University of Milan Bicocca. I'm presenting a work that I did with James Thomas from UCL in London, Rafael Peñalosa and Gabriella Pasi from Bicocca as well. The work is using an ensemble of features for personalized recommendations of scientific publications. So the context basically is the one of well-known of systematic reviews, where there are researchers that have to maintain their reviews, and as soon as new publications come out, they will be included into their reviews. We have tried to interpret the problem as a content-based recommendation problem. So basically, the existing reviews provide the current knowledge, and based on that content, the recommendation should happen in the correct way. Specifically, we are interested in the impact of natural language understanding in a domain-specific context, because obviously, the publication are highly text-based, and very often they are domain-specific. For example, they come from the public health domain or bioinformatics, so you need to understand the language. There are multiple angles, but the natural language understanding angle in domain-specific contexts is the one that is most interesting for us. In the initial phase of the research, we tried to leverage some structured information available with publicly available resources, like, for example, the Microsoft Academic Graph and the PICO ontology, which is exactly in the public health space. It's well known, at least in that domain. And they provide, for example, some structured text features like the titles and the abstracts of the publications. They're very easy to extract. They provide features about topicality, like, for example, the MAG provide the field of study, which is can be used for topicality. And there are some relational features as well, like, for example, the network of co-authorships, the network of citations, and many more. So, as you see at the bottom of the slide, a publication could be described by multiple vectors. So, for example, vectors of language models, so language embeddings, or TF-IDF vectors, or we could use adjacency matrices for relational features. So as a first step, we wanted to study the impact of all of these multiple features with those representations for our recommendation problem. And we wanted to make all the ablation studies to understand how much the text can impact and how much the current language embedding methods can provide good results or not, especially respectful to the other features. This is just an idea of the model. We actually didn't use nothing sophisticated. It was very simple, no machine learning, no deep learning. It was basically based on some cosine distance metrics between the vectors, and we used the train set for basically calculating some probability distributions and use some p-values to come out with membership likelihood. The model, as you see, is a multi-label classifier, basically. So it's pretty simple and worked reasonably well, but we were not interested in the results by itself. As I said, we were more interested in the contributions of the feature to the problem. So one step back, we have used a data set on smoking cessation, which has been manually labeled by reviewers. It's a real-life data set. There are around 13,000 publications belonging to 70 reviews, more or less. And the problem, the difficulty, the challenge of that data set is that it is highly homogeneous. So the labels, the 70 labels representing the categories are all for the same domain, which is smoking cessation. So the language is really homogeneous, and you really need to capture the important things to solve the problem. So what we saw basically is that text is provided important contribution, especially with TF-IDF representations. But when we wanted to raise the bar, we had to use all the other features together. Like, for example, the citations, the authors, while at the same time, the language embedding performed worse than TF-IDF alone. So our understanding of the problem, our current understanding of the problem, is that key phrases were winning in that case. So bigrams or trigrams representing very specific language artifacts important for the specific reviews were key to to the good performance. So what we do, because the other side of the medal here is the model is not standard at all. It is pretty simple, but it's not standard. It would be difficult to be applied to other situations like this one. So what we do, we could, the way we would like to follow at least is to merge language embedding with knowledge bases so that we can have in one way language embedding learning to extract knowledge, which is the next step of key phrases. And at the same time, we would like to learn representation of knowledge bases from language embeddings to make it explainable. So we will have hopefully language embedding, understanding knowledge and being able to represent that knowledge for explainability of the model. That's all. If you have any question, happy to answer.
Thanks. Question?
I have a question about the language modeling approaches you have compared TF-IDF with, because you told us that TF-IDF in your case were working better, but with embeddings did you use?
Repeat the question. So I understood you're asking which kind of embeddings we have tried, basically. So we tried several things, but the one that we tried most is BERT, trained over scientific papers. So the model is called SHE-BERT. That's the one we have tried most. We also tried ELMO, a little bit of BERT-based with some methods for aggregating vectors to represent abstracts. But they didn't work very well. So SHE-BERT was the easier.
Thanks. And the last talk is also going to be online. And I think it is by Mirko Maras.
Yes.
Let me see, who is that? Mirko?
Yes, I'm here. Can you hear me? Okay.
Hi, Mirko.
Hi, everyone. Can you see my screen? Can you hear me? Can you hear me? Okay, great. So I will start. So hi everyone, and thanks for all for being here. Yeah, today I will be briefly presenting our work on combining treatments against algorithmic bias in recommender systems, specifically focusing on biases related to item popularity. And this is a collaboration with Gianni and Ludovico, both from the University of Cagliari. So recommender systems rank items by decreasing relevance for a given user. And this relevance is often estimated through machine learning models. Therefore, the literature has traditionally focused on optimizing the prediction of user item relevances in order to improve recommendation quality. However, biases such as those related to item popularity that can be generated due to the imbalance in the distribution of rating per item, as we can see in this slide, can emphasize the occurrence of filter bubbles and damper recommendation quality and several aspects that go beyond quality, like novelty and coverage. Therefore, mitigating the impact of bias like this one becomes critical. Existing treatments for popularity bias mitigation are often applied in a single step of the experimental pipeline only. For For instance, in pre-processing, transforming the input data, in processing, including constraints into the algorithm, or post-processing, rearranging the items of the original recommended list. However, controlling bias by acting only in a single step of the pipeline could lead to suboptimal trade-offs between recommendation quality and bias. So one of the open questions is, what is the impact of introducing bias mitigation at different steps of the pipeline simultaneously, and how does this combined approach impact on popularity bias? In our recent work, published in the journal IPM, we addressed this challenge with a new framework for popularity mitigation. We proposed two new metrics that quantify how fairly a recommender system treats items. Then we empirically show that two major classes of recommendation models emphasize this bias by measuring it through the two proposed metrics. And finally, to counter this bias, we proposed a mitigation approach that is characterized by sampling technique for the training data and a regularization term that minimizes the biased correlation between item relevance and item popularity. In this talk, due to time, I will just briefly introduce the mitigation approach and some results. Our experiments were performed on MovieLens 1M, that is related to movies, and COCO 600K, related to online courses. We considered two personalized recommendation models based on a point-wise and a pair-wise optimization strategy that were chosen for their performance and wide adoption. And for each dataset, we performed an 80-20 per user training test split in a temporal fashion. As a treatment against bias, as I mentioned, we considered a combination of pre- and in-processing operations, performing a tailored sampling of the training data and a regularized optimization of the model. The proposed sampling of the training data varies depending on the model class. In a point-wise optimization, an observed user item pair is oversampled in an inversely proportional way based on the popularity of the item involved, while an observed user item pair is oversampled proportionally to the item popularity of the item involved. In a pairwise optimization for each observed user item pair, n triplets composed by a user, an observed item, and an unobserved item are created. And an observed item is selected from the items less popular than the observed item for half of the triplets, and from the items more popular than the observed item for the other half. This sampling ensures that an appropriate balance exists among the representation of the different items. Next, regardless of the model class, the optimization approach follows a regularized paradigm. It is formalized as a weighted combination of the original accuracy term, it is the original optimization function of the model, and a bias mitigation term that aims to minimize the correlation between the predicted relevance and the popularity of the observed item. And so the model is analyzed if its ability to predict higher relevance strictly depends on the item's popularity, regardless of the user-specific preferences. Then we empirically evaluated the proposed treatments by answering a set of research questions. I will present two of the most important ones here. And specifically, what are the effects of our mitigation components separately and jointly? And to what extent does the combined treatment impact on beyond accuracy aspects? First, we evaluated the influence of the pre-processing sampling and the in-processing regularization on model performance separately, and whether combining these two treatments can improve the trade-off between recommendation quality and popularity bias. To assess the quality of the recommended lists, we consider the NDCG score. The higher the score is, the higher the quality of the recommendations. To assess the item popularity bias, we consider our proposed metric that is called item equal opportunity, which encourages that the true positive rates for all items are the same. This metric controls that some degree of item popularity based on the representation in the dataset is preserved and maintained, while checking that no further distortions are emphasized by algorithmic bias on the final recommendation distribution. Therefore, this score varies between 0 and 1, and higher it is, the less the popularity bias is emphasized. And we can see here the results on ML1M. And we can see that the combination of our mitigation slightly decreased quality on the order of about 2 per NDCG points for both models. However, the increase in item equal opportunity with respect to no treatment or a single treatment is substantial when treatments are combined. On COCO, the combined treatment results in an improvement on both the quality and the item equal opportunity. This dual benefit may come from the fact that this dataset is more sparse, includes a very large catalog, and has a flatter popularity tail. And therefore, the combined treatment allows us to better capture preferences that in this dataset vary so much across users based on their preferences of courses. And finally, we investigated how the combination of treatments affect beyond accuracy aspects. The novelty of a recommendation, and we consider two metrics, the novelty and the coverage. The novelty of a recommendation is calculated as the inverse of the average popularity of a recommended item, while the catalog coverage is calculated as the percentage of items that appear at least once in the recommended list. And here we can see that based on the results on the combination of treatments, there is a clear gain with respect to the original model in terms of both coverage and item equal opportunity and also novelty. So we can see that combining the treatments has a very, very positive impact on beyond accuracy aspects. And to recap, we analyzed the impact of combining treatments to mitigate bias at different stages of the recommendation pipeline in a popularity bias Swift case. And we have seen that the combination of treatments resulted in lower popularity bias at the cost of a negligible decrease in recommendation quality. Our study sheds light on the discussion of the positive impact of bias mitigation treatments on beyond accuracy aspects, and calls also for a discussion on how to combine treatments that root out bias each stage of the pipeline simultaneously, rather than in a single step only, as we always see. Thanks for listening. If there are any questions, I'm happy to answer.
Thank you, Mirko, and we'll stop here. And this terminates the first session, the first day, and the cocktail should be waiting for us. Thank you all to other speakers and to all of you.
Ora sì. Ok.
Prova.
Aia, aia.
Ciao. Ciao a tutti, sono qui per presentare il mio lavoro dal nome Buongiorno a tutti, io sto presentando il mio lavoro dal titolo Come la dimensione. Quale fuori? Aspetta il microfono. Buongiorno a tutti, sono Luca Mancino e presento il mio lavoro dal titolo Come la dimensione delle poppe influenza la valutazione dei sistemi di raccomandazione.
Ora Alberto, ci senti?
Sì, ora sento Antonio.
Allora rientra.
Salve, buongiorno a tutti. Sì, salve. Allora, vorrei parlare da banco e vorrei dire viva il Dulce, torneremo. Io però non vi sento, io mi fido, cioè parlo,
Okay, Alberto, thank you. This is my question. Can you answer, please, to this important question? Thank you.
Yeah. Of course. Have you asked me any question? I can hear you.
Quando io parlo,
Cosa vogliamo mandare? Solo l'audio?
Tutti i partecipanti.
Tutti i partecipanti. Alberto, prendi il telefono e vai fuori.
Cosa hai cambiato, scusa?
Ti faccio vedere. Alberto, mi senti?
Stai fischiando?
Sì, ti sento, ti sento.
Dallo smartphone?
Sì.
Mi senti bene?
È un eco, con un po' di eco.
Ma tu stai fuori dalla porta?
Sì, sto fuori.
Perché rientri?
Perché rientra da qua? No, ora. No, no.
Alberto, mi senti?
Sì.
Alberto, mi senti? Mi senti bene?
Esci di nuovo.
Sì, sì.
Sei sicuro che mi senti?
Senza eco.
Si sente un po' di eco però.
Senti Alberto?
Ora sì.
Prova adesso.
No, allora sì.
Tanto apri Alberto. Allora, la domanda che ho per Alberto Mancino è questa. Perché sento così?
Con eco, Claudio, con eco adesso.
Mi senti con eco?
Sì, sì.
Antonio, vuoi provare a abbassare un po' il gain di questo? Che è il secondo? No, non il volume. Il gain. Niente, ancora eco.
Ancora eco.
Prendi il microfono. Come si sente?
Eco.
Eco?
Sì, ancora eco.
Non sento più la mia città. che mi culla.
Aspetta, sblocca il cellulare. Non ti senti, cioè ti sento che dal vivo, ma non ti sento dalle cuffie. No, non si sente.
Mi senti ora?
Ora sì.
Mi senti?
Sì, senza eco.
C'è l'eco?
No, non c'è eco.
Aspetta.
Qui c'è un po' di eco però.
Aspetta.
Qui c'è un po' di eco.
Aspetta. Non c'è eco. No, questo è un po' di riverb.
No, Claudio, non ti sento più adesso.
Antolo, hai spento?
Ora ti sento. Ora che quando
Mi
hai detto
senti?
Antonio hai spento. Ora sì.
Mi senti?
Sì.
Ok. Ciao Alberto, la domanda che ho per te è questa. Perché sei andato a vivere con Daniele in casa?
Ho sentito
Mi sa
la tua
che abbiamo
domanda
risolto.
senza eco.
Senza eco?
Senza eco.
Ok, bravo Claudio. L'eco di qua lo togli impostando correttamente i livelli del microfono. Questo qui ha un gain. Allora, devi abbassare un pochettino il 2. No, non il gain, proprio il livello del master del 2. No, il gain lo devi alzare, altrimenti che mazzo faccio? Alza il gain. Metti. Oh, sa. Devo gridare. Invece se abbassi il livello, lo metti a 3/4. Il 2. Perfetto. Abbassa un po'. Equalizza un attimo. No, quello non li toccare. L'effetto non è quello. Alberto, mi senti?
Sì, adesso un po' più sporco. Non c'è eco, solo un po' più sporco.
E adesso?
Bene.
Ok. Daniele, senti l'eco? Vabbè, però questo è fisiologico perché la stanza è vuota. Ehi, mo' è altissimo.
C'è il rumore adesso.
Sì, mettilo a metà. Alberto, mi senti?
Sì.
Pulito?
Abbastanza, sì.
Ok. Antonio, mi sa che abbiamo risolto. Alberto, parla un po'.
Prova, sto presentando il mio lavoro. Qui è il mio lavoro, sempre come la dimensione delle poppe possono influenzare i sistemi di raccomandazione. Comunque ci sono delle persone che ancora...
Prova.
Prova, sta.
Questo è un audio che ritorna dal... No, questo è un audio che ritorna... No, è impossibile fare un discorso in questa maniera, Claudio. Cioè, se tu provi hello everyone, io Antonio Ferrari,
Mi si sente bene?
questo è audio che ritorna dal computer e lo si percepisce chiaramente perché è audio sporco. Prova.
Ferro, ti si sente bene però.
Sa. Ok. Oh. Hello everyone. I am. Ora va bene. Ora va peggio. Pues dímelo. Sí, ahora tenemos eco. Pues dímelo, te lo voy a contar en español. No es que así no se puede hablar, ¿eh? Te lo voy a decir ahora mismo. Que voy a hacer un spoiler de La Casa de Papel, ¿vale? Parla, Alberto.
Prova.
No.
Provando.
Vamos a hacer el spoiler de La Casa de Papel. La temporada número 5. Pues que va a pasar en la última... En el último episodio.
Prova. Sto presentando la presentazione presentata
Claudio
da
si sente di merda però. Comunque ragazzi, io vi posso dire che comunque siamo in streaming su YouTube e in tutto ciò. Sì.
Prova.
Spero.
Prova.
A tutti i nostri visitatori su YouTube sappiate che queste sono prove tecniche e succede. Lo que pasa por la noche se queda por la noche. Vamos a hacer ese spoiler de La Casa de Papel, la 5ª temporada, que va a pasar en el último episodio. ¿Alguien lo sabe? Pues ¿quién se va a morir? ¿Quién se va a morir?
¿El profesor?
Pues que no me lo cuentes. ¿Puedo decírtelo?
Posso dirtelo?
Ma che cazzo ne so, ma mica l'ho visto.
Tocchio.
Veramente? E che ne sai tu?
Che devo fare? Claudio.
Perché è una cosa che fa sudare questo. No, vabbè, la potrei mettere pure domani. We would like to carry on. Come l'allenatore della Francia ai mondiali del 2006. Bravo, bravo.
Tommaso Di Noia has disappeared. Why Federico Narducci has taken the place of Tommaso Di Noia?
Can you...
Alberto parla? Si sente malissimo, senti. Alberto? Stai muto, Alberto? Alberto, sei in muto?
No, aspetta un attimo, mo vengo là un secondo.
Ora ti sentiamo bene. No.
Togli quelle cuffie di me.
No, le ha tolte e comunque non sono in mano.
Si collega automaticamente alle cuffie e poi si scollega.
Perché le cuffie le devi mettere... se le stringi fra le mani le cuffie si riattivano. Se le metti...
Che ne so io come funzionano queste cuffie?
Normale, se le stringi fra le mani...
Vai,
vai, scappa.
Normale.
Vai. Vai, Alberto, parla.
Sì, grazie per la parola. Vorrei spiegare i motivi per cui vivo con Daniele Malatesta. Penso che le dimensioni del suo membro
Daniele, come si sente, Alberto?
Un motivo che mi ha spinto a non vivere con Daniele Malatesta.
Alberto, parla.
Sì, esatto. Invece la vera motivazione che mi ha spinto a vivere con Daniele Malatesta è il fatto che lui si prepara il pranzo la mattina. Questo mi permette di occupare la cucina la sera.
Quindi l'audio da fuori ci siamo. E invece l'audio del microfono qua?
Eco però.
Vai a vedere ora se si sente l'eco ancora.
Parla?
Sì, parlo.
Senti l'eco?
Non Alberto, Claudio.
Senti l'eco, Daniele?
Un po' di eco si sente.
Sì, però volevo...
Ma pochino, non tanto.
E adesso invece?
Bene.
Però Alberto non mi sente.
Non lo so.
No, ti sento.
Alberto, ci senti?
Io sento sia Daniele sia Claudio.
Nel momento in cui... Però Alberto ora si sente? Cioè, se Alberto vedi che
Prova.
Alberto?
Parla.
Prova. Sto provando.
Alberto?
A
Can you hear
spiegare.
us?
Sì, vi sento. Provo a spiegare perché appunto vivo con gli anni nel mal di testa e, come già detto, la
Alberto,
motivazione...
mi senti?
Sì, ti sento.
Sì, ma tu con l'eco.
Sì, aspetta, Daniele, aspetta. Alberto, continua a parlare.
Sì, allora dicevo, la scegliere di vivere con gli anni nel mal di testa non è stata una scelta facile, sicuramente è stata vagliata, è stata valutata, però alla fine il fatto che lui si prepari il pranzo la mattina è stato un fattore
Daniele, senti
determinante.
l'eco?
Soprattutto nel
Alberto no, ma a te ti
in
sento un
una
po' con
casa
l'eco.
diciamo
adesso?
Ancora sì, un po'. Ma un riverbero più che eco.
È un fattore determinante nella
riverbero?
scelta.
Sì.
Sapendo che mediamente i fornelli hanno circa, o meglio, i piani cottura hanno mediamente 4 fornelli, questo implica
Come mi
che
senti,
non
Daniele?
più persone
Adesso bene. Parla di nuovo. Parla.
cucinare.
Invece te ti sento con l'eco qui dentro.
Se non...
Eco, no, vabbè, è un riverbero.
Diciamo, se non potenzialmente...
Alberto, tu mi senti bene?
Sì, benissimo.
Ok, proviamo. Ok, questo può essere un buon compromesso. No, Claudio è troppo. Prova. No, troppo poco. Questo potrebbe essere più o meno. No, un altro po'. No, adesso è successo qualcosa. Vai un po' più su di volume. È il massimo. E dammi un po' di guadagno. Allora, questo potrebbe essere un compromesso orrido per quando, diciamo, sta facendo la domanda a qualcuno da là. Alberto, tu continui a sentirmi?
Sì, bene, ti sento bene.
Ok, allora questo potrebbe essere un buon compromesso per quando stiamo... Che hai fatto? Poi a un certo punto, quando finisce la presentazione di là, togli il computer praticamente, giusto? Ma c'è eco ancora, perché? Abbiamo messo troppo guadagno probabilmente. No, quello deve essere attivo. Ma eco ce n'è parecchio. Sì, alla fine proprio. Ora Alberto, tu non mi senti?
No,
Sì,
ti sento.
E mi sente ancora, Claudio? Devi togliere il guadagno del computer. Tolto? Ma se continuo ancora a sentire del riverbero. Ora no.
Io sento sempre Antonio.
Ok, ora è pulito. Abbastanza. Monitor. Questo? Prova.
Antonio, ti sta chiamando Felice.
Alberto?
Ti sento.
Ok.
Scusa, mica funziona. Non funziona. Ah, sì.
Allora, ok guys, è troppo riverbero ora. Togli un po'.
Hi everybody, can you hear me? Can you hear me?
1, 2, 3. Troppo, Claudio.
Can you hear me? Hi, can you hear me? Can you hear me? Loud and clear.
Troppo basso.
Yeah, but I'm also shouting, so.
Da qua non si sente.
Sto gridando, però non lo so se è per questo.
No, raga. No, Claudio.
Ehi.
Vai, prova. Direi che no, in realtà è tranquillo, però non si sente nessun riverbero. No, non si sente. No, aspetta. Guarda, prova. Allora sono le casse in quel momento sono le casse, però credo di no. Vedi? Se tu ti metti qua, tranquillo. Le casse, vedi, dovrebbero essere queste qua, vedi?
Prova a parlare, Daniele.
Prova.
Eccomi, sono qui.
Avvicinati un po' perché sennò non ti si sente.
Sono qui, eccomi.
Okay. A Daniele sta di riverbero, qua è risolto. Risolto, rispetto.
Prova. Good morning, everybody.
Okay, guys, good morning. This is my presentation. My presentation is the best one here. Diciamo che questo più o meno.
Good morning and welcome to IIR 2021.
Alberto, tu ci senti?
Sento entrambi.
Bene?
Sì, bene.
E voi lo sentite forte e chiaro?
Forte Mario, sì, forte Mario. Good morning and welcome to IIR 2021. I'm your chair for this session. Yeah, a bit of echo, you know?
Ma dove cazzo ho messo l'erba?
Good morning, my name is Daniele Maritesta and I'm a first year PhD student at Politecnico di Bari.
Ho lasciato a casa l'erba, porco
Nike,
Dio.
gone or
Mi
not?
senti?
Yes.
Mi senti Alberto?
Sì, ti sento, Claudio.
Senti, Gianmaria, com'è l'audio in sala adesso? Vai a sentire un attimo tu, che forse ho inquadrato il
Gone. Should I go on? Good morning. Yeah, I'm delayed in life.
Ciao a
in general.
tutti, bentrovati. Questo va benissimo ora. Questo va benissimo.
Good morning. Good morning, my name is Daniele Maritesta and I'm a first year PhD student at Politecnico di Bari.
Ora va bene anche Daniele. Ciao a tutti, sono... se riesci in tutto ciò a dare un poco più di volume, anche sul master. Ok, ciao a tutti. Dai un'altra goccia. Perché non tutti hanno la voce proprio squillante. Ok, good morning everybody. This is my important presentation. Vamos a decir
Good morning also by me. Vai Alberto, go on Alberto.
Good morning also by my remote presence at the IIR 2021.
Alberto, puoi avvicinare per bene il microfono?
Yeah, I'm pretty near to the microphone.
Ok. Ora va meglio, sì. Ora va molto meglio.
Pretty good, I think.
No, mo di nuovo il riverbero a te.
No, I don't think so. Hi, can you hear me?
Yeah.
È tornato un po' di riverbero a Daniele.
Can you hear me?
Ora sì. Vai.
Can you hear me? I'm a first year PhD student at Politecnico di Bari.
Ora va bene. Ora va bene.
Pretty well now, I think.
No, togli un pochino.
A little bit.
Ad entrambi.
A little bit.
Ok. Non toccare Daniele. Alberto, ci senti?
Sì, io vorrei toccare Daniele.
Ok, toccami pure.
Alberto, prova ad avere una voce abbastanza squillante.
Sì, ciao, buongiorno a tutti. Siamo qui collegati da Radio Virgin Radio.
Ok, aspetta, ora mi mettete una canzone dal computer?
Ciao a tutti, in questa notte calda siete carichi?
Vabbè, chi hai cambiato?
Ci sentiremo per la prossima ora e mezza. Vai Alberto, parla.
Dolce casa, Alabama, dove il cielo è sempre blu. Dolce casa, Alabama.
Questo non cambia niente.
Sala ricevimenti,
No,
eventi, meeting, Torre Giulia.
Il monitor
Panini, cornetti, triangoli.
Strada statale 100, chilometro 24, Torre Giulia, non mancare. Questo programma è offerto da... in collaborazione con...
Sì, ma devi darmi il tempo.
In collaborazione con Pino Carni, Macelleria.
Possiamo spegnere la presentazione su YouTube?
Rosticceria da Giulio, tutto quello che volete.
Tolgo?
Sì.
Tolgo qui? Oh.
Un attimo, possiamo spegnere la presentazione YouTube?
No, adesso voglio che uno prenda un attimo YouTube e vada a sentire come si sente il tutto.
Vai Alberto, prendi YouTube e senti da YouTube come si sente qua.
No, no, Alberto rimane là che deve parlare. Prova.
Yeah. You're so hot tonight.
Raga, guardate che comunque è tutto in streaming.
Capire che caso sta guardando. Ma sono prove, sempre nel meme, ricordatevelo.
Io sono in remoto ed essendo in remoto non potete sapere
Veramente?
cosa sto facendo con le mie mani. Sì, sì, mi ci si sente? Mi ci si sente?
Togli un po' di questa musica.
Daniele, mi senti?
Alberto, ciao, benvenuto ad IIR.
Ciao, grazie Antonio. Ho sempre desiderato essere qui.
Ok, questo è il meglio del volume che riesci a darmi?
Claudio è soddisfatto? Sì, così è bello, c'è un po' di voce roca, però così penso che vada bene.
Perfetto. Possiamo andare. Fatemi fare la foto, se ritrovo il telefono.
Ce l'ho io il telefono, Antonio.
Ah, giusto. Claudio, ma il problema è che sto streaming, quello rimane tutto su YouTube poi caricato.
Sì, bisogna buttare il video caricato e ricaricato.
Che devi fare, mo? Ehi, togli un po' la musica, togli un po' la musica.
No, deve stare la musica.
Perché?
Devo sentire se
Certo che si sente.
Scusa, dammi il canale di cosa, voglio vedere quanti stanno. Ah, no, bugia, non c'entra niente.
Si sente, no?
Vero? I microfoni si sentono.
La musica.
Zero spettatori, quindi nessuno ti sta cagando.
Ti senti per forza, perché quello è lo stesso da dove entra l'audio di Zoom. No, non ti senti. Vabbè, ormai tanto, vabbè, comunque. Sì, non ti preoccupare.